I'm going to pull up the first presentation. That'll be the introduction to soils. Second one, our second module will be a obtaining and finding land, how to go about it. And our third module will be how to pretty much get your land cleared, prepared, and ready for farming, whatever you want to, whatever you plan to do. So I'm going to share a screen now with the first module, and we'll get going on that one. Just give me a moment, and we'll let's see here. Yeah, just give me a moment here. Trying to figure this out. Okay. Can everybody see this?
Yep, I can see it.
Okay,
Yeah,
so
looks great.
everyone can see it. That's great. All right. So basically, we'll get started. So we're, as Mark mentioned, it's going to be basically sort of a series of presentations and modules that's going to go through right from an introduction to soils right up to all the complexities of various crops and cover cropping, regenerative agriculture, carbon sequestration. It's pretty much all those topics that people were interested in, what we're kind of calling new agriculture, which is kind of a misnomer, as it's sort of we're kind of going back to the old school ways of doing things and being ecologically minded and working with nature instead of trying to work against it, and also trying to get the agriculture into a more carbon friendly methodology and system. So we'll get started right away, basically, with our introduction to soil. So soils is basically a collection of natural bodies on Earth's surface containing living matter and capable of supporting plants. That's the basic description of soil. There's 100 different, you can go extremely in depth with it, but basically that's the gist of it, and basically what I just said. Without plants, there's no oxygen, there's no life, there's no people, no animals, no anything. So it's very important, and it's just something to keep in the back of your mind as we go along, basically. Soil is basically made up of four main parts. The mineral composition, which is basically broken down bedrock into the your particles that you'll see, which are in your hand. The sand, silts, clay, rocks, gravel, all that sort of stuff is the mineral matter, and that's where a lot of inert nutrients and stuff come from. And believe it or not, soil looks pretty solid, looks pretty thing, but basically, almost 50% of it is pore space in between all the grains, the granules, and the aggregate. Typically, organic matter makes up about 5%. Now that seems pretty low, but that's quite a bit of organic matter actually in soil, and many, many, many places don't even have that much organic matter. And there are some, like say the Amazon rainforest, and places where it never gets a winter and it's a constant addition of organic matter that may have a little more. But 5% is a average, and it's kind of something that we strive to maintain or increase to get to if we don't have that much. The organic matter is where a lot of these it's living, it's dead organisms, it's rotten vegetation, dead animals, living animals, microbes, bacteria. There's quite the variety of different things that are in there. But this is just a quick breakdown of what soil is comprised of. And why soil is important. There's a lot of stuff right here. I'll just go to the diagram to show it a little better. And basically, it's kind of self-explanatory. I've kind of touched over it already, but basically it helps to purify water. It helps to regulate climate. Soil is one of the biggest carbon sinks of anything on the planet. It's twice what the atmosphere pretty much holds for carbon. Soil is a great nutrient recycler. It's a home for all organisms. It's where most of our food comes from. It can be sort of a historical. What we've learned quite a lot from looking at different things, archaeologists and all this sort of stuff. Soil holds records of our Earth's history and timeline. Basically, it's the foundation for all of our structures, and a lot of building materials and medicines, different things that come from soil and the organisms and the plants that live in the soils. Basically, this day and age with the global warming crisis and the extremes in our climate and of droughts and rain events and things that we've been seeing, everybody's been seeing it worldwide, and here we've been seeing quite a bit of it ourselves as well. That we get massive amounts of rain in short amounts of time, or we get, much hotter weather. So carbon sequestration is a big topic that's going to be covered in a lot of the later modules. I'll slightly touch on it as we go through these, but it's just another thing. Soil is a huge sink for carbon, and with this carbon credits and all the things that are going on, soil is going to play a much bigger role in basically carbon management, global warming, and even on a larger economic scale. So it's not just farming and plants that we're worried about. It's going to be a lot more things that soil is important to. Um, this definition saying soil is a renewable resource. Well, if you lived a couple of thousand years, yeah, it's renewable. But basically, soil is a very, very, very slowly renewed resource because it takes a long time for soil to form. And if you ruin soil or degrade it or strip topsoil from an area in our lifetime, your grandkids still won't see any decent soil put back in that place. It takes thousands to millions of years for soil to form. And that's why it needs protection. And that's why we have to sort of manage it better than we have been, and to maintain our soils and to keep them productive and still maintain a level that can feed the world and provide all the resources that we require from soils. Like I said here, we're getting into a little introduction on how soils are created. Basically, weathering is the main factor that creates soils. There's a lot of different aspects to weathering that happens, and we'll go through some of those now in the next little while. So basically, soil is formed over a long period of time, and it's a combination of a number of things, but mainly there's three main aspects to consider, and it's physical, chemical, and biological factors that break down rocks and organic matter, and then work to combine all those into a soil profile or a soil pedon that we see when we dig a hole, when we do agriculture or any type thing. So basically, weathering, rocks break down through different processes like wind, water erosion, temperature change, freeze and thaw, gravity, chemical interactions, and to a certain extent, some pressure differences. Um, Organic matter decay, basically plants decay, microorganisms like bacteria and fungi and various things like snails and other organisms are very important decomposers. They take this dead plant and organic matter, they consume it, and in the process, there's a biochemical reaction that happens inside the animal when their waste basically creates a form of nutrients and organic matter that plants can reuse once again. So it's a big cycle that goes through, and all these organisms, all these processes, without even one of them, basically none of this would work, and we still would have a very desolate planet. Um, I won't worry too much about this, but basically in the bottom little term there, that's a very important thing to consider. Typically, it takes about 400 years to form 1 centimeter of topsoil. So like I say, if you destroy it, ruin it, remove it, you're not going to see it again in your lifetime or even your grandkids' lifetime, basically. So it's just something to be aware of, that soil is not renewable, and it's something that basically we need to protect and manage very well. And this is just a quick little diagram to show over a long period of time how soil is formed from barren bedrock, basically. Mosses, lichens, that sort of thing are the initial weathering agents that happen. And as they work, and then slight little cracks in the rock, basically with water going in, freeze and thaw, breaks it up. And over time, water and temperature change is a big factor that happens. Slowly, organic matter breaks up and basically starts to build up and compile. And then over a long period of time, thousands and thousands of years, we'll see soil horizons start to form, and soil will look like what we see now when we dig a hole this day and age. There's basically 5 factors that help to form soil. We've slightly touched on them already. Basically, the 5 things that need to be considered for soil forming are the parent material, basically the bedrock or the glacial till or whatever it is that basically the soil gets derived from, as this stuff gets broken down by weathering into smaller and smaller particles. Climate, climate is very big because basically, depending on where you are, the climate can be very warm, very hot, and soil forming and biological processes can be very accelerated. Or you can be in very cold climates like the Arctic and various tundra areas where basically soil formation is very slow. And even since the last 10,000 years with glaciers departing and retreating, there are very many areas, even in the province here, where it's very little change has happened in the 10,000 years that have happened. Organisms, critical, very important. They provide all the organic matter that's in the soil, and they also do the intermixing of the mineral and organic matter to create our soils. Um, Time, I've mentioned time already, and then the type of topography and landforms also have a big part in how soils are formed and the rate of soil formation. So parent material is basically the base product that soil is derived from. And typically, most times in the world, it tends to be from solid rock, bedrock. When there's bedrock decomposes, breaks down, gets weathered. And then the glacial tills, basically, from when glaciation was here. Glaciers acted like giant bulldozers, basically, and they stripped material from one area as they were moving over. And as they melted, they dropped all this material in various ways and in various places. Um, and like I say, the soil is kind of derived from the parent material, and it kind of keeps some of those characteristics, some of the things like color, texture, the soil structure, and the mineral composition is based on the underlying base bedrock or parent material that created the soils. And the little picture, you can't see it all that well, but basically, this is a soil that was derived from an area that's predominantly red sandstone, and the soil has that sort of distinctive red color as well. You can see it in the province at times, out around Bishop Falls, Grand Falls. The highway is like a reddish color, and it used to be out around the Butterpot area recently until they just paved it again. So the bedrock has a large part to play, and the color and a lot of the things that create the soil. So knowing your geology and your bedrock can also assist in knowing where to get your soil and what kind of soil you could expect to find in a certain area. Climate, I won't waste a lot of time. We've already kind of roughly gone over this, but basically, climate influences the rate of soil formation. Very warm climates, soil formation is faster. Cold climates, it's slower. So basically, every increase of about 10 degrees Celsius, biochemical and biological reactions sort of double. It's just a quick idea just to know. And the main points of climate are basically moisture and temperature. I mentioned organisms. There are so much in the soil. Basically, one spoonful of soil could have almost a million or millions of microbes and bacteria and all that sort of stuff in there. None of that's visible to the eye, obviously, but they all play an important role in doing this. So we've got our fungi, our algae, we've got numerous plants that do all kinds of different functions, our microorganisms and our macroorganisms, which most of you are very familiar with. Typically, if you see a soil and there's earthworms in there, usually you have a decent soil and your pH is usually pretty decent and it could be okay for growing crops. Not a guarantee, but it's a good indicator. There are lots of different indicators for finding decent soil and determining soil health, and we'll touch on some of those throughout the presentations. So relief and landforms, basically I stated, if you have a very steep topography, you can expect landslides and colluvial material. Gravity has a part. As material is weathered, it falls down to the base of these slopes and starts to build up. And pretty much even now to this day, basically topography plays a very important part in where you can expect to find suitable soils for agriculture. Typically in our province, it tends to be our hilltops and the upper slopes that have the better soils. They've had better drainage and they've had more time to have soil forming processes go on. And typically you'll find deeper soil and deeper profiles on the crests and the upper slopes of most of the hills in Newfoundland. As long as they're not bedrock, basically the crest of a hill, the rule of thumb for us is crests are best. This quick little schematic is just a quick showing of all the different sort of landforms you'll see, and very indicative of what we see in our province as well. You can see in the background, it's just bare bedrock mountains that have been stripped bare by glaciation. You'll see a nice vegetated hillside here. Typically, on a lot of these is where we'll find some of our good soils. And in some of these raised terraces and benches by lakes, water bodies, oceans, and river systems and stuff, you can find some decent soil there. Unfortunately, most of Newfoundland, our valley bottoms tend to be excessively stony, bouldery, and rocky. So we don't get a lot of real good valley bottom farming in the province unless they were sort of washed by glacial rivers and tend to be sands and gravels and that sort of thing. But typically, anyone knows around here, you've been on the creeks, rivers, and streams and stuff. They're almost all tend to be very stony and bouldery, and even the shorelines and lake shorelines tend to be similar. So you need to get up a little bit in elevation away from those to get away from that, and then you get into decent soils. But typically, it's our hills and our ridges and our upper slopes that hold the best ground for farming and agriculture. And you can see that most anywhere you go around the province, you'll look and you'll see they're almost always on slopes or hillsides. Rarely is the good farmland found on flat, low-lying ground. And time. So I've gone through some of the soil forming factors already. I won't worry too much about this slide here. It's just a quick showing a quick thing on profiles, and soil development is really slow. So if you have horizon development, like layers in a cake, basically that's an older soil that's had good development. If there's very blurred or very vague horizon development, it tends to be a younger soil or a very slow forming soil. And in Newfoundland, we've had about 9 to 10,000 years of soil formation since the last glaciation retreated, which geologically speaking isn't a very long time at all. So the fact that we have a foot to a foot and a half of soil, of good topsoil in places, is pretty good for here, considering the time and our climate. Um, So basically, soils can get deposited and put into place in a number of different ways. A lot of material, glaciation was probably one of the largest things that affected our whole North American, Canadian landscape and Newfoundland as well. Very few areas were not glaciated, and it's kind of something that basically underlies. Typically, most of Newfoundland has glacial till as a parent material that a lot of our soils are deriving from. But this is just a quick definition. I'll just throw some visuals up here to show these, basically, the modes of deposition, how it happens. And most of you have probably seen this or been kind of familiar with it. So alluvial river deltas, that's basically where a river system ends and it goes into a large body of water, be it pond, lake, or ocean. Water slows down, all the sediments and all the stuff it picked up through erosion, it gets dropped out, basically. Typically, in some places of the world, like Mississippi river deltas and all these places, these tend to be quite fertile and very productive sites. Unfortunately, in Newfoundland, we don't have a lot of these that are suitable. So, like I mentioned before, most of our stuff tends to be upslope, sort of, and on the hillsides. Lacustrine basically was giant inland lakes or glacial lakes or small inland oceans. There's not a whole lot of that also in Newfoundland. The prairie provinces are very indicative of this. They have a uniform, very deep, very fine textured soils, which were basically lake deposits. And, from dust blowing into the lake over tens, thousands, millions of years, this stuff is formed. And you can see from the man stood there, some of these deposits can be very deep, but not typical for our province of Newfoundland and Labrador. Marine deposits. This is pretty common in Newfoundland. We do have quite a bit of different deposits in Newfoundland, and typically areas where there is shale, which is a good proportion of the Avalon Peninsula. It basically started out as a shallow ocean floor, and due to tectonics and over time got pushed up, and basically just compaction causes these to be solid and turn into a type of a bedrock, sedimentary bedrocks, basically, which we have quite a bit in the province, and particularly on the Avalon Peninsula. A lot of shales and sandstones and siltstones comprise the bulk of our geology. It's quite common in places to see shellfish even digging down 100 feet into the into soil profiles, various quarries around the province. I've seen this where they quarry out sand and gravels and stuff when they get to a certain point with if you're within several kilometers of the ocean. Because when glaciation happened, the weight of the ice, which was typically at times a mile thick, it put a lot of weight on land and basically pushed our land down, sometimes 100 to 150 meters. Once it melted, we had what we call was rebound, and this stuff came up. So basically 150 meters above sea level today, you can go into certain places close to the shorelines and oceans and still find this kind of stuff in some of your areas. Glacial fluvial. This is basically as the glaciers were melting, we've had a number of rivers, small lakes, ponds, all that flowed underneath the ice. And in the process of doing that, it carved out numerous valleys, and over time, it laid down layer after layer of washed sands and gravels. So, it's not that great to see on this picture, but it's very defined when you're in the field and you see these stuff. And typically, where Department of Highways have all their depots and quarries, this is stuff that's very valuable for quarry material, and it also tends to where we find some of our best agricultural land. So it can be disputed. We're trying to get this land. If we want it for agriculture, a lot of other people and entities want this kind of material as well. That's just another quick visual showing an area. This was a place in Newfoundland out around Botwood. And we get into our horrible glacial till, which unfortunately is predominantly the main parent material or subsoil material that we'll find in the province. And it's just an unconsolidated mess of basically everything from the smallest particle of clay up to the largest boulder that you could possibly imagine. And this stuff tends to be very, very, very compact and cemented. So it's very, very hard to dig into and to do. Even mechanized equipment can have a good struggle in trying to dig through some of this stuff. And this is just an example of glaciation done, and this is the evidence to show us that it actually happened, is these erratics and stuff. Anywhere Witless Bay line, out around Holyrood, many places in the province, the Southern Shore, Cappahayden area, you'll see tons of examples of this kind of stuff, and it's pretty prevalent around the province. And they're pretty interesting to see. It's amazing how they just sort of stay and are balanced, and it's almost like a giant was playing and set these up. Wind deposits, very, very minimal in our province. There are some very small localized areas where this is the case, more so out towards the west coast of Newfoundland. And anywhere where it's sort of sandy, like, Eastport, there might have been a little bit of this. And if you leave your soil bare, wind can affect, and you can get a little bit of wind erosion from this. But typically in Newfoundland, glacial fluvial and glacial tills are our predominant soils and parent materials that we're dealing with. Just an example, deserts, wind erosion. Won't get too much into that. We don't have many deserts in Newfoundland. We have lots of barrens, but no deserts. And then gravity-based colluvial, as I mentioned, the steeper the ground, the more material will fall down slope and accumulate down when the slope levels out. So basically, we've had the soil forming factors and properties, but then there are processes. Once all this stuff happens and the weathering and stuff occurs, the organic matter has been piling up, then how does it all come together to create soil? So basically, I've gone over the weathering pretty good, but I won't get too much into it again. So basically, decomposition and humification, that's where, it all kind of comes together. That's when basically the minerals from the weathered bedrock gets kind of incorporated with the organic matter. And that's where all these biochemical and biological reactions that happen are super important, whether it's through lichen, algae, fungi, microbes, bacteria, or other sort of nematodes, and even larger animals that burrow in the ground and stuff like that. So it kind of covers everything. Everything kind of helps to mix all this together to make a productive living soil layer, basically. Leaching, that's pretty straightforward. It's a downward movement of water through soil, which happens when basically when rainfall exceeds evaporation. So in Newfoundland, we've got a very wet climate. Drought is rarely an issue. Too much water is typically our main problem, and water management is a big part of any farm in the province typically, and not just farming, but for many other activities, be it construction, house construction, roads, any of that kind of thing. And it basically takes nutrients from up in the surface and brings them down through the soil profile down to a certain depth. Translocation, that's kind of movement of material. That's where a lot of these nematodes and microorganisms and even larger animals come into play. They move material and nutrients and various things through the soil from the surface down lower, from down lower and upward. Capillary action is usually something that happens in areas where evaporation is more than precipitation, drier climates. We don't see a whole lot of that here, except for maybe on our wetlands, our bogs, and in our peat and that sort of thing. When it gets really, really hot and dry in our 2 weeks or 2 months of summer that we typically get, you can see some of the bogs. This could happen. Basically, water moves upward. Same thing as putting a paper towel in a glass of water. You'll see the water go move up the paper towel, moving upward away from the actual water. Um, so once soil gets formed, there's a what we call soil structure and aggregation, and that's how sort of the soil particles bind to each other. And there's a number of different ways, depending on the soil type, the size of the particles, and the amount of different organic matter and the organisms living in the soil all play a big role in this. And it's kind of important because soil structure is what maintains those pore spaces to allow for oxygen, air, water, roots, all this root penetration, all this stuff. So soil structure can be destroyed pretty easily in a number of ways, and we'll get into some of that a little later. But I just wanted to do a little introduction to it, and it's very important to know, and it's very, very intricately related to your soil texture, which is basically a mix of your particle sizes and everything that's in there. So this is kind of a good schematic of showing a soil basically aggregation and a soil structure. As you can see, all the different particles that are in here, you'll see the different spaces in between the particles that are here. And it doesn't take much to cause compaction or ruin your soil structure. And it takes a fair bit of time for it to re-evolve or reform. So, it could be decades if you ruin soil structure initially, that it could be years to decades for it to get back to this state where it has air spaces and pores. So basically organic matter and roots, fungi, all that sort of, they give off an enzyme that kind of helps bind these particles together and make the different aggregates that we'll find in soil. Sometimes you'll dig a hole, it'll be all fine and powdery and fall out of your hand. Sometimes it'll be in clumps. Sometimes it'll be in sort of flat layers. That's what we refer to as soil structure, basically, how it's sort of clumped together when you're digging it and you remove it from a soil profile. And I've sort of touched on why structure is very important to maintain the pore space, permeability for water. If you ruin your structure and water can't infiltrate your soil, you're looking at a lot of runoff and then potentially erosions, and quite a lot of destruction can happen up and downstream of the area that's being eroded. Um, Trafficability is something that's probably most important here, and if you're into agriculture, you'll hear quite a bit over the next few modules and stuff that were going to happen. And that's basically stating, how susceptible is a soil to soil structure, the de-evolution, basically. How can you can ruin the soil structure. Um, and friability, trafficability is kind of hand in hand. Friability is just basically stating how what the tendency of a structure to be degraded is, how tough is it to resist, being degraded and getting destroyed. Um, Soil structure is very important, and this is just going a little more in depth to what I've kind of already said and what we showed in the first circular diagram of all the importances of soil. Basically, the soil holds so many organisms that it's one square foot of soil probably has more microorganisms than people on the planet. Pardon me. Um, Earthworms, very important. You've all seen after a rainfall, all these dew worms come up to the surface and leave a pencil-sized hole in your soil, basically, or your grass. So they're very important for keeping structure, maintaining structure, and among everything else of mixing all the soil particles together and combining mineral and organic matter to create living soil. And plant root systems are also a big part that helps to increase structure and maintain structure, and then basically infiltration by water to get into there. It's very complex, and some people have done PhDs just on soil structure, soil textures of just certain soil types in certain places of the world. So it can get very involved. I'm just barely scratching the surface here because this is just an introduction to soils. And if anyone has more questions, we'll answer those sort of later on. Uh, Agricultural productivity, which is something huge. Everybody has to eat. Um, Everyone can see that with our climate change and things that are happening, prices of goods and commodities and foodstuffs have skyrocketed through the roof. And just being able to feed everybody, regardless of the cost, is something that's going to be a huge issue in years to come. Also, food, water is just as critical as food is, and soil is massively huge for filtering water and cleaning out many pollutants and that sort of thing. And basically for landscape protection, for water protection, and to protect all sort of fish bearing sort of things, that's where soil structure it plays a role in everything. Climate change mitigation, something I mentioned earlier, and it's an issue that's going to become more and more prevalent as the years go on and the population grows and more of these severe weather events are seen and noted. And like I mentioned before, it's one of the biggest stores of organic carbon of anything in the planet is our soil, and it can be a very good asset to pull some of this carbon that's causing our global warming and put back into the soil. And there'll be a number of methods of that discussed later. As I mentioned, the types of soil structure, when you pull out a handful of soil, what's it look like? What's it doing? This is just a quick little schematic to show that there's different types. And depending on how deep you go in your soil, your structure will change as well. And this is just showing a quick thing of what I mentioned going down through your profile. You'll see different sort of soil structure as you get down through. Typically, when you get down into the sea horizon, which is your glacial tills, it's extremely compact and it's what we sort of call massive. It's just no formation to it. It's just just a complete glob of everything all mixed together and frozen like cement. So basically, there's a number of properties to soil. When we're doing our assessment work, we're trying to determine is an area is suitable for agriculture, or it could be for engineering purposes, it could be for construction, it could be for anything, but we're focusing mainly on the agricultural side of things. And there's quite a lot of things that you have to consider basically. There's something we like to call the big nine, and that's basically what we look at when we're out doing our quick soil assessment work to determine what a soil type is and then what it can be used for and the best way to manage it. So without looking at all these sort of properties, we don't know what kind of soil we have. We don't know how it's going to react to certain practices, and we don't know what the best way to manage it and use it would be. So all these are pretty important. We'll go through some of these as we go through the slides, and we won't get overly in depth, but it's just good to be aware of a lot of these. Basically, I mentioned color is a reflection of basically the parent material or the bedrock that it was derived from. Texture also is from all that, and structure and texture are pretty closely related because with textures, if you have a silty, very silty clay sort of soil, it's very small particles and it compacts very easily. It can shrink and swell quite a bit. Versus if you have a sandy soil, you can get your drainage can be really well, and that's where you can experience sort of drought conditions. You can have a much lower nutrition level. So it's just important to know that all these are here, and there's a lot of them that come into play. Shrink swell potential, that has a direct influence on a lot of things. And in Newfoundland, we see a lot of it. In the springtime here, you'll see a lot of our roads tend to get lumpy and humpy and bumpy, and you can even see basically places where puddles have dried up. You'll see that the soil is cracked and shrunk as well. And this can have an important part in certain crops that you will grow if your soil type is this silt-based and has a lot of shrink and swell potential. It's very important to know, and it can be, it's just another tool in your management toolbox when you're doing agriculture. Porosity, permeability, they also kind of go hand in hand. Infiltration, drainage, everything's pretty much interconnected. So you can't just mention one without kind of thinking about all the rest of them. And I'll just leave it there for now. We'll get into this a little bit more as we go through. Texture, and basically the basic definition of it is the proportion of sand, silt, and clay in a soil. Most all particles that aren't considered coarse fragments, which is sand, gravels, rocks, cobble, all that sort of stuff. Sand, silt, and clay is what we look for when we're determining a soil texture. And the different proportions of those can vastly change your soil type and your management practices and what you can do or can't do on a certain soil type. Just an example, some soils are loamy sand. It can be loam, silt loam, clay loam, silty clay. A lot of the Avalon Peninsula is high in silt because it's derived from a sedimentary bedrocks, and it's something that we have to consider quite a bit of, and you will see it. So like I say, right here, the best soils are those that have 10, 20% sand or clay and silts with a high proportion of sand and at least a couple of percentages of organic matter. 5% is what we try to get to. A lot of places don't have that, and at times you may never get to that. But that is what we try to get to, and that's sort of a good number to have when you're doing your soil. If you do soil testing and you see you're into the 3 to 5% organic matter, you've got a pretty good amount of organic matter in your soil and you get a lot of biological activity. So basically, when we're determining texture, just going to be a very quick view of it. This is what we call a soil texture triangle. And when we do a test on certain soil types, we determine our percentage of sand, silt, and clay. Then we'll go to this here chart. It has the 10 main forms of soil types that are here. And we can determine our soil type, and then our management practices and many other things can basically derive from knowing our soil texture. It's pretty simple to do, and it's not overly complex. Once you know your percentages of your sand, silt, clay, this is a pretty easy exercise, and you can determine your soil. And staff here at Agriculture can assist with this. There's a number of different methods that we can use, sort of that you don't have to get too fancy or get overly expensive or wait a long time for laboratory results. This is what we typically use in forestry and agriculture and other, even mining and energy. This is sort of a, you can't see it very well, but it's just to know that it's out there. It's just sort of a quick texture, a rough texture test in the field when you're out there. There's a bunch of things you can do to get a decent idea of what your soil texture is. And also, this is something that we kind of used to do with sort of students, but anyone can do this as well. It's basically taking a sample of your soil. You basically want to screen it to take out all your gravels and your bigger fragments. So you're left with just your sand, your silt, and your clay, basically 2 millimeters and smaller. And it's just put it in a jar with a little bit of water and a tiny little bit of dish liquid. Give it a good shake, and then over a certain time, after 1 minute, you can measure how much the sand is settled out. After about 7 hours, you can measure how much of your silt, and after 2 days, you can see what your clay percentage was. And you measure the total over those. It gives you your percentages of your sand, silt, and clay. So it's a pretty simple little process that you can do at home if you don't have a lot of time to get to labs, or if you don't have a lot of whatever. This is just a quick and dirty little way to get a good estimate of what your soil texture is in an area. I mentioned before the particle sizes, basically sand, silt, and clay. Clay is microscopic. You cannot see an individual clay particle, basically. Silt is almost microscopic that you can't see an individual particle. But sand, you've all seen sand. You've all been to the beach. You know that there's all different sizes of sand, up to 2 millimeters, basically. After that, we get into our coarse fragments, which is what everyone typically generally would call rocks. In the agriculture and soil side of things, rock is basically referred to as bedrock. So we use our terminology for the different sizes of the coarse fragments in soil, such as gravels, cobbles, stones, boulders. Gravels are stuff like pebbles, from the size of a tip of a pencil to the size of your thumb, top of your thumb. Cobbles tend to be from the size of your thumb to about the size of your fist. Boulders tend to be slightly bigger than fist size to about the size of a basketball. And then boulders typically can be anything from 2 feet to 10 feet. That's just a quick breakdown of the coarse fragments and the terminology that we'd use in soils, in engineering, and anything that has to do with this. So it's not just rocks anymore. I know everyone calls them rocks, but typically when you're in agriculture, we refer to rock as basically bedrock. So that's anything 10 feet or bigger. And I've just pretty much gone over all this. I won't get to it. It's just a quick, very good visual to show soil is 2 millimeters and less. Everything else is considered coarse fragments in that soil. Um, well, I won't worry too much on this, but just sort of determining, clay, silt, sand. Sand is pretty easy. Silt and clays, they can be very similar to each other and they can have a lot of similar effects on your soil. But this is just a quick way to say, and I'm just showing that it's, you can't see an individual grain with your fingers. And this kind of comes into play with that field texture method I showed you the sheet. There's a little flow chart to find. This is just some of the criteria that we kind of need to know to determine if what type of stuff we're into. Like I said, sand, it's pretty simple to determine. So that's basically just the pedogenesis, how soil forms, that sort of stuff. This next little section is going to go through soil profile and horizons. And this is probably what visually is the most important for you guys that are interested in agriculture and farming, because this is what you will physically see when you dig a hole, you dig an excavation, you do whatever, roadside cut, ditches. You can see all this stuff in all that area. You've all seen a fence post hole dug. That's basically what we do to determine a soil profile or a soil horizon. And basically, horizons are like layers in a cake. Typically, there's several horizons in a developed soil, and the thickness of those horizons is determined by landscape, climate, all those things we mentioned before, basically. So the hilltops and upper slopes have been soil forming for a longer time. Typically, you have deeper soils and deeper horizons, whereas on a steep slope, material due to gravity and erosion has been washing downslope. And you would think that at the bottom of most of the hills, you have a much deeper soil profile, but unfortunately, due to drainage problems and water holding up in perched water tables, our lower slopes tend to be much slower forming soils and shallower, and typically lower in nutrition and typically have more drainage and problems of that nature. So basically, the basic study of soil profiles, and what we call a PDON is a soil unit. Won't get too much into that. That's more for sort of soil survey side for, mapping large areas of land and what soil scientists would do. But for you guys as the agriculturalist or getting into farming or being new and an introduction to it, just to know that there are profiles in the soil and they tell a lot about the history and the capability of that soil, that from visual and chemical testing, basically, in a soils lab. And it boils down, there's maybe four main layers that you will find basically in a soil. So this here is a good visual of just showing, the main types. You've all seen basically dug a hole, you've got your organic matter on the top. Then when you get down, typically in Newfoundland and a lot of places, we'll see this little thin layer. It can be very thin or it can be up to a couple of inches thick, and it's usually a light color, pinkish, whitish, gray, and it's what we call the A layer. And it's basically where a lot of the nutrients have been leached out due to rainfall and precipitation, and they've been deposited into the layer just below it, which is the B horizon, which is this one here. And that's typically where most of our roots. I know this diagram isn't showing the roots down in there, but this is just sort of for a visual effect, not an actual sort of really what you see in nature as a soil profile. But just giving you that you have your organic matter, you typically get this leached layer. Then we have this B layer, which is an accumulation layer where most of the nutrients and the minerals that have leached from the organic down to the A accumulate right here. This is the topsoil, basically what you're seeing when you're doing any type of gardening or doing soil work or anything. Typically, then we'll have a C horizon, and that's the parent material. That could be glacial till, it could be bedrock, it could be a number of different things. And then we get down to the unweathered bedrock. Eventually, you'll hit rock somewhere, no matter how deep you go. So this is another quick little visual. It's probably a little bit better representation, not with the root side of it, but just showing that we have this organic layer up on the top. We have this A layer. Now, I don't particularly like how they're the same thickness, but it just gives a good visual. Typically, this A layer is fairly thin, a couple of centimeters, a couple of inches at the most. This B horizon is where the most important, basically, is where most of your rooting happens. A lot of the biological activity is going on in here, and that can be anywhere from several inches to several feet thick. And then once you hit into this parent material, that's what we call subsoil. When you see in construction, they'll strip off all these B and A and organic layers. They want to get to the subsoil, and that's usually very compact and solid, and it has no soil forming happening whatsoever, and it tends to be very acidic as well. As I mentioned, the pedon, I'm not going to worry on this too much. It's just how we measure if we were out doing soil surveys, and it's typically a meter by a meter by a meter deep, and you just study all aspects of the soil in an area, all the different horizons and everything else. So here's some good visuals, and this is what you can expect to find in many places in the province of Newfoundland and Labrador. Um, as you can see in both of them, we've got our organic and our vegetation up on the top, typically what we'll call an LFH. That's our O layer, and it just refers to litter, ferrous, and humus, basically. So, and then we see this white right here. This is the A horizon. Um, that A horizon takes a long time to form as well as the B horizon. So it's a very good diagnostic tool for a number of things, especially when it comes to land claims and that sort of thing. If someone said they farmed years ago, and if you go in and you find this still intact, then this soil hasn't been disturbed because it takes thousands of years for this to form. And then right here, we'll see our B horizon is our soil. And this is a much better visual for showing where most of the roots and your biological activity is taking. The definitions on the bottom, the ferrohumic podzol, that's not overly critical and important, just to know that typically Newfoundland are mainly podzol soils. And it just goes back to the family of soils and landscapes across Canada. It's just a way for soils personnel to name different soils. And when you talk to anybody worldwide, they would know the exact same thing, just like all the Latin nomenclature for animals and plants and that sort of thing. These are some actual samples from around Goose Bay, Labrador, where it's all typically very, very sandy, and it was a glacial sand outwash where most of the soils were formed. So they typically have some deep soils. In the small areas that do have good soil in Labrador, they tend to be deep and sandy soils from glacial fluvial deposits. And these can be some of the most productive soils that we have in the province. And as you can see on here, I won't get too much into it. It's giving us a quick organic. The little A horizon can be black or it can be a whitish gray, typically black with a lot of organic matter in it, or it's a whitish, grayish, pinkish color where most of the nutrients have been leached out and deposited down into the B horizon or your topsoil layer where most of your rooting and your plant growth occurs. This is also from up in Labrador, and it's a really good visual with a nice deep roadside cut that was done that we got some pictures of. And you can see your organic matter on the surface, your A horizon, and then there's not always just one B. They'll name the B horizons typically on color, the texture, all different sort of things here. So you can see this BH they're calling here has a lot of organic matter accumulated. In this C, it's very dark colored, so there's a good mixing of the organic matter into this iron-rich sort of layer of soil. We get down here, it's kind of a little bit lighter color. It could be a transition zone, or it could be also a lighter, less nutrition-based BF. Between the parent material and your B horizon, often there's a layer called BC, and that's the transition layer between parent material and your nice productive topsoil, your B horizon. But this is a good visual to show what you could see in a lot of places, and this is pretty typical what I'll see digging soil profile holes across much of the province. And once again, this is just showing different ones. I wanted to put this one in just to sort of show. I know the pictures are somewhat small, but basically show there's a quite a thick AE horizon going into your B horizon here. Here we've got quite a thin, kind of discontinuous AE horizon. This one here, there's almost none, and it's just a very wet soil, what we call glacials, and they're pretty much saturated year round. Stuff you'd find in depressions and drainage channels and valley bottoms and that sort of thing. Basically, it's pretty much wet for most of the year. Um, Besides having the compact sea horizon, often in different layers in the soil, we can get what's called cemented layers or hard pans, which most people have heard of. And they can act much in the same way as what the subsoil and the parent material is. And it can prevent water infiltration. It can prevent root penetration. It can cause a lot of problems, basically. And that's why Newfoundland is quite common. We get a lot of perched water tables due to cemented horizons or layers of this type. This is another example, basically. And there's a number of things that make these cemented layers. You can see this really thick organic mat on the top, and a lot of iron has been seeping down through. Well, right at the contact between the bee and the parent material, nothing can infiltrate here, so you're getting lateral movement to the waters, one side or the other, and it's accumulated a band right here, which is almost just like rusty iron, basically, is what it looks like. And that can prevent stuff as well. So if it's shallow, then you want to break this. If it's fairly deep, then you may be okay. But it's good to know. That's why you need to have soil profiles and look underground to see what you have to know what's going on. These are a couple of sort of the soil types. In Newfoundland, we've got about 150 different soil types throughout the province, and we name them based on the region or some particular thing. And this is just a quick thing. Typically on the Avalon, a lot of this part of the island, this is the types of soils that we'll deal with. And the Cochrane Association is sort of pretty dominant on the Avalon, and in the Cochrane soil itself is some of the best. So just a quick visual, our soils are really, really stony pretty much everywhere. So this is just a quick visual showing, and this is taken on a hilltop or an upper slope, and that's where we'll find some of our better soils. We've got kind of a A, B instead of an A here. It's kind of mixed between the organic and the B horizon. So you can see this, it's a grayish, lighter, sort of darkish, it's a bit of a mix. Here's your topsoil, and you can see along here all your rooting is taking place from this point upward up to here. Our Pooch Cove 1 is kind of found in our mid slopes, and there can be some slight drainage problems with this, but typically our Cochrane and our Pooch Cove occupy the crests, the upper slopes, and mid slopes of our hills. Our Pooch Cove 2 is typically lower slope and anywhere where sort of benches out along the slope, and you can see it's a grayish with some minor rusty modeling going on here. A lot of standing water down in here. Pooch Cove 2 soils tend to be excessively stony, wet for most of the year. Some of them can be ditched or drained and put into production, but quite a lot of them, it's not economical really to put them into production. And we finally get to our valley bottoms, our depressions, our bottoms basically below a bog. What you're going to find is a torbay soil. It's a very compact, typically glacial till. It's saturated. It's got a bad smell when you dig it up, like a bog does. And it's just basically saturated almost all year round. And they typically occupy the lowest points where water is flowing or standing all year round. These can almost never be put into production, and they're best maintained as the natural drainage channels anyway. I'll give a quick brief on climate change effects on agricultural soil. It's going to get a lot more into it in the next session back in February. I guess this will be the dominant topics, the climate change and regenerative agriculture. This was just an introduction to soils, and this is also just a small introduction to how climate change has effects on agriculture soil. We've all seen things from around the world. We've seen them here in our province. We've seen these mass rain events. We've seen times our temperatures are getting hot and staying hot for longer in the summer times. And when we get these rain events, they are just intense over a short period of time. So erosion and runoff is something that's becoming a much bigger issue in the province. Um, the incidents of these happening are increasing, so we've got to kind of get a little bit inventive in the ways we do farming, and manage water control is becoming even more important than it was before. And it can also have a big effect on nutrients and nutrient cycling. If you've had fertilizers in an area, you get a heavy rainfall, that's all washing off and going to flow down to the lower points and end up in waterways or water systems, which has a negative effect on those as well. More soil-borne disease, a loss of organic matter, increased compaction, because if you work wet soils, it's the worst thing you can do is to put heavy equipment on ground that's saturated or really wet. It just causes a lot of compaction, ruins your soil structure, ruins your drainage, and can extremely increase erosion. Increased risk of forest fires. That's something that's been predominantly, especially in Western Canada, that's been a huge issue out that way. So it's just something to consider. Um, there's a lot of different practices that are coming on board and have been prevalent in different places around the world, and things that we're starting to adopt. Um, so, enhanced carbon sequestration, boosted biodiversity, better crop resilience and yield. That's extremely important with the growing population and our climate change. Reduced chemical use and pollution, improved farm profitability. Everybody wants to make a good dollar and everybody wants to have a good product. But with our changes and things that are coming, we've got to do things a little differently. And basically, agriculture and all these different methods that'll get introduced throughout the different modules will be very important to know. I mentioned in the very beginning, without topsoil, there's no life. So we need to keep it and manage it as best we can. Bare soil is bad. That's the new sort of thing. Basically, we don't like soil left bare for a number of reasons. It allows we can have, in the winter time without snow cover, we can have desiccation, which actually kills a lot of microorganisms in the upper horizon. It can kill your grasses or your plants that are also there. And also, nitrogen can volatilize and go back into the atmosphere as well. And carbon can also be much more prevalent at being released from the soil when it's a bare soil, as biological activities in the summer and that type of thing can be increased, and they're typically up at the surface. Things like cover crops, green manure, uh, strip cropping. There's a whole different bunch of series, a bunch of activities that you can do to help promote fertility, reduce carbon and nitrogen loss and or erosion. Your organic matter loss is a big one as well. That's a big problem many places around the world. Also reduce your how much time you spend on that ground, how much heavy equipment is going over there, causing compaction, loss of structure, erosion, drainage problems. Certain things like planting perennials and native walled vegetation, they typically tend to be deep rooted. So if you've had some structure issues, compaction issues, using these can help to remediate soil after it's been damaged and help improve all these aspects: porosity, infiltration, drainage, and root penetration. There's a bunch of different ways we can do that. We can use different crops, we can use animals, we can use machinery, we can use technology. But it's just good to know that there's a lot of different problems we can run into, but there's also a lot of different solutions that we can use to solve that problem. But the basic does boil down to knowing your soil and having the basics of some soil science behind you, basically, to know what to look for so you can know how to fix something. This is just a quick little visual of some of the various things that we can do to maintain a healthy soil. adding organic matter, compost, manures, that type of thing, green manures, plants that you have a winter cover crop that you'll till back into the soil, reducing tillage. Instead of clearing a whole field, you can clear strips and leave the rest vegetated and just plant your crops into strips. That way you have much less bare soil, you have much less machinery activity, much less compaction, and you'll maintain better drainage as well. And rotating crops, that's going to be a big part of all this discussion in the next few months to come. And that basically covers the bulk of just an introduction to soils. And if anyone has any questions, you can feel free to send them my way. And that's the end of the first module. Our second module, if there's no questions, our second module is going to be basically how to obtain some land in the province. And it's just going to go through how you find land, the processes you have to go through, what organizations and entities you have to deal with, how to apply, what paperwork sort of involved, and that sort of thing, and fees and all that. So I'll get into the next module. Here.
Hello.
Hello.
Hi. I was trying to type my question, but it wouldn't let me. I'm just wondering how, like, if you're going to take soil samples for agriculture, how close together would you take them? Like, would you do every half acre, every acre?
With regards to soil sampling, typically, a lot of times you'll have some sort of mapping of an area if you're going. If not, basically what we're looking for is a one per acre is good, but you can do combined samples. So if you had a 5 acre an area, it's fairly similar. There's no upper slope, lower slope. There's no wet depressional areas or anything of that nature. Your vegetation seems pretty similar throughout. You can just take a blended sample. So if it's 5 acres, you can probably just walk with a bucket and a shovel, take maybe 6 to 10 samples throughout that 5 acres and blend them all together and basically just make a sample out of that. Typically, what I look for is changes in landscape or changes in vegetation or visible changes in drainage. So if you got a very low-lying area, you want to sample that sort of separately from your mid-slope and your upper slope stuff, like the top of a hill. You want to sample the top of the hill separately and down lower because there'll probably be quite a difference in your nutrition and pH and all those factors. So one per acre is good, but if you've got, pretty similar ground, you can just take a 5 or 10 acre parcel that's all pretty much the same and take a dozen, 10 to a dozen, digging at different sites and then blend that all together into one sample. And typically for our lab, we're looking for about a half kilogram. So pretty much a sandwich bag full.
Okay, great. Thanks so much.
Oh, no problem. And we've got on our website, there's a pretty good visual, and I might show it through our slides through the next process here too. Basically, it just shows you gives you a good idea of how to sample, like what part of the soil you want to take. You want to take your sample from the area where all the roots are going on. So typically your A and your B horizon, that's where you want to sample your soil. You don't really want so much of the surface organic matter, and you don't really need to go down into the parent material or the subsoil. Typically, subsoil is always a grayish, blackish sort of color when you get down to it. But basically, yeah, so you want to take it from the living soil, basically where your roots are happening, where all your growing is going on, is where you want to sample from.
Sounds good. Thank you.
Oh, no problem at all. All right, so any more questions? If not, I'll go into the next module on obtaining land and how to find it and how to get some. Okay. All right, I'll pop into the next module. Everybody see this on their screen?
Nope, we don't see it on this
All
end.
right.
No,
All right,
not
one
yet.
second here now. And how about now?
Here we go.
Yep.
That's all.
Yep.
good.
Okay. I'm kind of new to this one. I haven't used Microsoft Teams a whole lot. I've been using Zoom and Skype for the most part. So there might be a few little glitches, but we'll work our way through it. Okay, our second module. And if I'm going too fast for anyone, just let me know, but I'm just trying to get through. It's a lot of material to go through, and I just like to get through. And if there are questions in between, just feel free. You can stop me and ask a question as well throughout. Don't have to wait till the end. At the end is better, but if you don't have to, if you got something now, if you're like me, you wait till the end, you might forget what your question was. All right, so our second module is just obtaining land for agriculture. And people in the province think that there's a lot of land, and there's a lot of land in Newfoundland. There's forests, there's plants, there's trees, there's stuff everywhere. So soil must be everywhere for farming, but unfortunately, that's not the case. As this slide shows, in Newfoundland, we have a very limited suitable land base for agriculture for a number of reasons. Like I mentioned before, when you fly over the province, you see it looks like the bulk of the province is water, if not, or bedrock, basically. That's probably 70, 80% of our province is wetlands, barrens, or bedrock, basically. And it's not, none of it's suitable for agriculture. So what we're looking for basically are forested areas. To a certain extent, some of these barren areas and heath areas can also be productive sites. But typically, forested areas are the dominant agriculture areas in the province, and that's most of where most of the farming is occurring, is on areas that have been cleared of forest, pretty much. And I know it might seem counterintuitive with the carbon side of things and global warming to take down a forest and put in agriculture, but sometimes these forests are over mature and they're basically in a decline stage, and there's a lot of dead and decaying matter. So basically, carbon output is higher than what oxygen output is. So, clearing some of these and putting in vigorously growing crops and plants is actually helps, and actually helps take more carbon out of the atmosphere than it does. So you can't just look at something real quick and say, okay, that's bad or that's good. There's just a whole lot of things that you have to consider. And that's just one little point I wanted to make. So Newfoundland is a very limited amount of land that's suitable for agriculture. Our estimates, based on some of our preliminary soil mapping and our capability mapping, say that roughly 1% of the province is suitable for agriculture. That's it's not very much when you look at it. And like I mentioned before, it's when you fly over, it makes more sense, I guess, when you see it for yourself. It could be up as much as 3%, but 1% is the number that we've been throwing around for the last 50 years. And that basically boils down to a land base twice the size of St. John's, a couple of 100,000 hectares at the most. And that's not a lot of land, basically. And of that 1%, half of that might be inaccessible in places so remote that we just can't really get to economically. It could be under various different land uses. A lot of the good land you'll find is where residential and where towns and cities are as well, because they were the flat land where it was easy to build on, and early settlers needed a place with a little bit of soil to grow subsistence crops for themselves to survive. So unfortunately, a lot of our good soils are under houses and buildings, roads, and all that sort of stuff right now. And finding the amount of soil is very hard. So like I say, our jobs are pretty difficult trying to find this stuff. And then when we do find it, we like to make sure that we conserve it, preserve it, and keep it, so it's not taken by something else and it's there for future generations. Um, Most of what I'm speaking of is going to be mineral soil, which you call dry ground, I guess. But wetlands can also have are very suitable for growing various numbers of crops and doing various agricultural things on. With the global warming side, taking peat, and causing, it could be counterintuitive, but with our very limited mineral land base and with the excessively stoniness of our soil, growing crops like carrots and parsnips and things like that like a nice sandy soil, and they long go right. With a lot of our mineral soil, it's just too gravelly. The texture is too fine or too compact that it's tough to grow some of these type of vegetables, and that's where organic soils like dome bogs and stuff come into play. Now, there's a bunch of different challenges and a bunch of different things to deal with when you deal with the bog, but we have a number of people in the province currently using bogs. The bulk of them are probably for turf production, sods. It used to always be on mineral soil, but now most of it is on organic soil. Vegetables, cranberries, wild bake apple harvesting is pretty big in parts of Labrador, and forage and pasture to a limited extent. But the vegetables and the sod production is pretty prevalent in the province, and there are dozens of cases of people doing it right now. So it's just something to consider down the road that, bogs are actually useful and we have an awful lot of them. So if we can make use of even 1% of those, then we've just doubled our agricultural land in the province. Um, kind of briefed over this already going down through, but 10,000 years ago was when the last glaciation retreated from Newfoundland. So most of our soils in Newfoundland are considered juvenile soils. We do have horizon formation, but in places it's pretty minimal and very thin horizons. So it's just to know that it takes a long time, and it's not something in our lifetime that we're going to be able to remediate if we screw it up, basically. Newfoundland soils tend to be very acidic. We're in the boreal forest ecozone, and basically all these coniferous trees and plants just tend to be very acidic just due to their nature and their physiology. And all basically our organic matter is derived from the needles, leaves, cones, branches from all these sort of plants and trees. And that's why our soils tend to be pretty acidic and tend to have low fertility just due to being juvenile soils and our short growing seasons that we have. It has a limited amount of time for these reactions and our biological things to occur. So almost always in Newfoundland, we have to use a fair amount of lime to get our pH up to a suitable level. And quite often fertilizers are required, whether they're chemical fertilizers or organic fertilizers in the form of kelp or manures or that type of thing. So, we can't just clear ground and go plant right away. It takes a bit of preparation to do. Um, Other limitations, like I've mentioned already, almost everywhere in the province is excessive amounts of coarse fragments from cobbles up to boulders. We get a lot of drainage problems, and our topography is extremely fragmented. So you rarely find 100-acre fields in the province here. You'll find always the guys will have a series of ridges or hills, and they'll have the upper slopes and the hills will be cultivated with all kind of wetlands and drainage areas all in between them. So it's a complicated place here. It's not like you see it out in the States in the prairies. You'll see just all everything laid out in squares or circles. And most of our fields here are very irregularly shaped, and there's not many square or nice fields like that around here. And like I said, basically we're in a boreal forest ecozone, acidic, kind of wet, sort of cool climate as well. We get excess precipitation for the bulk of the year. And basically topography is one of our biggest restrictions for land use for agriculture in the province. And for a number of reasons. Just once you hit about 15% slope, it becomes a bit hazardous to run some heavy equipment and tractors and farm equipment. So it has to be careful. So, 15% doesn't seem like a lot of slope, but when it comes to certain equipment, machinery, even erosion potential, it can be quite significant. So you want to go farming, you want to find a piece of land, and basically this is how you go about it. Three main things that you'll have to worry about is it available? And that's where our land use atlas on the Crown Lands website comes into play. You can actually, if you're interested in an area, first thing you got to make sure, is it available? Can it be applied for? Can I get it, or is it tied up with some other use? Is it private? Is it underneath some departmental, whatever? There's 100 reasons why it could not be available. So that's very important. Accessibility. Can I get to it? Is there access to it? Is it too far away? Is it massive bridges involved? All this kind of stuff, because stuff does boil down to economics in the end. If it's not economically feasible, you're going to go broke and you're not going to be there for very long. So economics plays a part in pretty much everything in our life this day and age. You can't get away from it. And then I guess then once those two things have been decided, it's available, you can get to it, then is it suitable? And that's what we'll discuss quickly through this module here. Land availability. So basically, like I said, the Crown Land Use Atlas is a great tool to look on to see if an area is available or if it's already under title or if it's inside type of reserve or whatever it is. So most of the farmland in Newfoundland is on Crown land and it is in different forms of land tenures. And the three main forms in the province are Crown lease, which probably dominates most of our farmland in the province and our agriculture as well. And it's typically a 50-year lease, $4 per hectare, and it's renewable. So as long as you're going, even you can transfer it to your children, you can transfer it to someone else to keep it in agriculture if that was your wish. So it's a very, very low cost. And it's basically it's our way of trying to help promote agriculture in the province to keep that price very low. 'Cause I'm sure places in the world charge a lot more for leasing land and whatnot to different entities. Crown licenses, they're typically another entity. They're signed for 5 years, renewable. I think there might be about $25 a year rent or something like that. Typically don't require a survey. And then there's your private land, what we call crown grants or freehold. And that's been private land that's around. Now in Newfoundland, that can get a little sticky at times due to a lot of records missing and paperwork and whatnot. But private land can be tough to determine sometimes in certain places. So the availability of land is very important. Like I say, nothing else matters unless the place is available. There's no point wasting any time or energy on trying to do something if there's a piece of land tied up for some reason or it's unsure, even if you're not sure what could be there. Sometimes it's better to stay away from it and just go for an area that you know is available. So like I said, the leases, I've given a quick over those. They're given for basically you have specified terms basically that you have to meet if you get a crown lease, whether it be for mining, for agriculture, for residential. There's a bunch of different things, but for the agricultural side, there are conditions when you do an application, you'll get these conditions that have to be met, which kind of just, is compliance. And we do checks, and if you're not compliant, we can take the land back from you. If you're given land for agriculture, you're supposed to use it for agriculture, not build a house, not strip all the topsoil and sell it. And that's all happened in the past and probably will happen again in the future. But basically, we just try to keep our limited agricultural land as agricultural land. And leases are one of the best tenures basically to keep that land in thing. So we can take it back if you're not doing it for farming, and we can give it to somebody else that's going to do farming or keep it for somebody in the future. They require a professional survey. There has to be a land survey conducted on it once you apply and then submitted to the Crown. The cost is at yours. Sometimes as a new farmer, a young entrant, that's into the program side of stuff. There is probably some funding that can help assist with the survey or part of the cost of the survey. Agriculture development officers and our website will give you much more information along that side of it. Like I mentioned, if you're not compliant and you have a certain period of time to clear a certain amount of land on your lease. And fortunately, if most of you will have some type of mapping, suitability mapping for soil done by us or somebody, and the compliance will be based on your suitable area, not your total land area. Because as I mentioned, our landscape is so fragmented, you're going to have to take in some unsuitable land just to keep your boundary reasonable, basically. Because if you put every corner and every line in a survey is costing more money when you do your land survey, and it gets very convoluted. So, if you're lucky, if you take 100-acre parcel, you're lucky to have 40 to 50 acres in that parcel that are suitable. There's just no way to get around it sometimes because our landscape is so fragmented. Pardon me. Crown licenses or LTOs, license to occupy, they're generally for smaller purposes. Not like a lot of our agriculture isn't on crown licenses. Occasionally they tend to be, but they're for smaller instances such as hobby farms, which might be just a couple of acres. Home gardening typically is a half acre. If we deem you need land for, if you're doing gardening at your home, you don't have enough ground and you need some more. That's where this kind of thing comes in, and we'll do a half acre. Road accesses tend to be licensed to occupy, ATV and hiking trails, sawmills, wharfs, water access. All these are basically examples of what Crown licenses would fall under, and they're typically for 5 years, renewable. I think they're about $25 a year. You don't need a legal land survey for them before they're issued, which is a sort of a cost save there. They also come with compliance conditions, and they can be canceled if you're not doing what you're supposed to do with the land. You don't meet those conditions. And this is here just a link to the Crown Lands website. Crown Lands website, Agri-Foods website, and the Crown Lands Land Use Atlas are three great resources for you to find out a ton of information, all about different programs, methodologies, people that can help, and everything else. We've got people in all different aspects of agriculture. We've got crop specialists, fertility specialists, soil specialists, land specialists. So there's a wealth of information here that can really assist you, and looking at those websites is a good resource to allow you to find the person you need to help, or you can probably help yourself by finding the information on those websites. Pardon me. Crown grants, private land, freehold, that's all basically sort of the same thing, and there's quite a bit of it through the province, and up till maybe in mid-70s, a lot of agricultural land in the province was issued in this way. But as you know, we've had problems, people selling them to someone else, commercial, residential, stripping soil, quarries, you name it. So the Crown Grant thing is a bit more so for the commercial side of stuff, for residential or cottage lots, that sort of thing is where more the Crown Grants come into play. With agriculture, typically almost everything now is a lease. That way we've got better control of the land, and if it conditions don't get met, we can take it back and maintain that land and not lose it to whatever that comes down the pipe. As I mentioned, there's a lot of different programs out here that can be availed of, but these are just a couple that are our way of trying to maintain our 1% of our agricultural land and keep it as agricultural land. Um, People that have where a lot of land was private and sold and gone back in the day, a lot of it's just sitting idle, forested, or just grassland. So we have a land consolidation program where if the land is deemed suitable, we'll buy it back from private land and put it back into the Crown land pool. And that's been going on now for a number of years. And we've taken quite a few parcels of private land and put back into the Crown land pool, but only if they're suitable for agriculture typically. Another one, if people don't want to sell their land, but it's sitting idle, and we have a lot of farmers that are just crying out for land here in the province, basically, and it's hard to get it, within a reasonable distance of where their farm base is. So this property tax exemption thing is allowing people with private land, someone can use their land. It's basically a agreement between the farmer and the property owner that the farmer can use the land, and then the town or the municipality will provide a property tax exemption to the landowner. So it's kind of a win-win for both. If they're sitting on land, not using it, it's good for agriculture. Let somebody in agriculture use it, and you get a tax break on it as well. And in the agriculture development areas and land freezes, what they call, there's a couple of places in the province where this is actual legislated law. I believe Wooddale out around Grand Falls and the St. John's actual ADA. There's a large portion of land that is frozen in this area, and it's legislated by law that agriculture is first use. And even people who have private land in these areas, they can't just randomly go build houses on it, do whatever. They've got to go through the government and our department to submit proposals to see what they're doing. And small little pieces and portions get removed from it every so often, and parts get added to it every so often as time goes on and things change. There's a number of them across the province, but only those two are actually legislated by law to be agriculture first. We've also got a number of what we call AOIs. They're areas of interest. It's places that we found throughout the province near communities and residential areas where agriculture is most preferred. and we found decent soil. So these are what we have. They're not so much legislated, but agriculture is a preferred first priority, and they are kind of it's policy more or less than legislation. And they're basically on our land use atlas as well, that you'll find a lot of those. And that's a good resource just to get started, to have a look if there's somewhere close to your area and there's one of these AOIs there. It's a good possibility that you could get in there, and some of the hoops you have to jump through are already taken care of with these, so you probably wouldn't be starting directly from scratch on a new piece of land. So it's just something to consider, that these are things, tools that we have trying to maintain our small pool of agricultural land in the province. It is just a quick map showing some of the areas, and typically our AOIs tend to be by larger population centers where people are. We're not going to be out in the middle of nowhere because it's just inaccessible, uneconomical for a whole bunch of reasons. So mainly, it's always a battle to find nice ground near residential and to keep it as close as possible. So that's where our 1% and some of these mechanisms come into play. And when I mentioned accessibility, it's pretty straightforward. It needs to be accessible, close to markets, close to the intended farmer or homestead or your residence or whatnot. You need to be accessible by road, and you can't be landlocked. Basically, what I mean by landlocked is if you're on a road system somewhere, most towns, all the frontage is owned or private or leased, or some form of land ownership is on them. If you can't get behind to get to some of this suitable land, then it's considered inaccessible and landlocked, and government won't issue a crown lease if we can't get a public right of way into it. So if you owned 100 acres of private land and you want to get 100 acres behind you as a crown lease, you would have to give up a right of way piece of your land to be able to access that, because we won't give out landlocked land. It's just something to consider. And for reasonable distances, there's a program in our government farm road access program, and up to maybe a kilometer or two, depending on what happens, we'll actually build a road into your lease boundary to get you access to the lease. Once you're at the boundary, the road and everything inside the lease is pretty much up to you then. And suitability, that's the big one, is very little of our land is suitable. So determining suitable land takes a fair bit of work, and it's a lot of time involved, a lot of man hours involved, or woman hours either. We have 3 soil personnel basically in the whole province that are finding all this stuff. So we're quite busy, and we do the best we can with what we have and finding these suitable lands. So, it's in your best interest. If you're interested in a piece of land, you can do your due diligence and go take a walk and take a shovel. You can check some of the soil and stuff like that. But if you're unsure or you just want to be sure, then contact us. And whenever a crown land application goes in for agricultural land, it gets sent to us soil personnel, and we typically will have to go out and inspect that area for suitability. We'll create a map, and we'll tell you where the best stuff is and the best way to use it and everything else. So it's a really good resource to use. Doing it on your own, you can, but you should avail of our assistance whenever possible, because it just makes your chance of success much greater. So regards to soil suitability, I mentioned earlier, there's the big 9 sort of things that we look at. So we look at fertility, soil structure and texture, the drainage conditions, soil permeability, and water holding capacity. They're all hand in hand. The stoniness, depth to bedrock, and the topography. So, rooting depth, soil depth, drainage, the amount of stones and coarse fragments, the position in the landscape, all this is really important, and it's the main sort of things that determine our suitability. And once I mentioned, we've got a lot of resources on online, website, and personnel that can assist in this. A little tiny bit more in depth into the criteria we look to. So like I said, Newfoundland soils are pretty infertile, have low fertility, almost always have low pH. A good indicator with pH is if you find earthworms in soil where you're digging, typically you've got a pH of about 5.5 and higher. Most crops in Newfoundland we like to grow in are between 5.5 and 7 on pH scale. And basically, pH is just an indication of the soil. It's not so much like adding lime to get your pH higher. It's not a fertilizer. It's what we call a soil amendment. What it does is basically, if you have a soil with a low pH, you can throw as much fertilizer on it as you want, and it's not going to work. Because with a low pH, all these nutrients and fertilizers just get locked up. They can't be taken up by plants. They're not bioavailable. So as soon as you hit that 5.5 and up, you go from maybe 20% available to up to 70 to 80% available. So that's the one thing I just wanted to emphasize, that lime isn't really a fertilizer. It's a soil amendment that makes all other fertilizers work properly. So getting your soil and your pH to a good level is critical for everything else to follow. Soil structure, texture, we've kind of gone over that pretty good already. Basically, it's good to know what you have so you can know how to manage it well and manage it properly and not destroy it and ruin it and have problems. And then drainage conditions. Typically, wet areas, you dig into the soil, you probably get a bad smell from the anaerobic bacteria that are going on there, like hydrogen sulfides and sulfur and that kind of smell. Also, it tends to be a blackish gray, blue color with lots of rusty colored modeling and stuff going on. And a lot of times you'll see standing water there. So it's a pretty good indication. You get nice horizon development, you get nice colors without any modeling. Typically, that's a site where you have good drainage. And permeability is related directly with drainage and stuff too. But basically, it's a big part of precipitation and erosion. If you have a good soil permeability, then water can percolate into your soil and it will do what it's supposed to do. If you've got bad permeability from compaction or from whatever, then basically you're going to get a lot of runoff and you can have erosion, loss of nutrients, loss of organic matter. A whole lot of problems come from bad drainage, basically, and poor permeability. And water holding capacity is kind of related to texture. It's really sandy, gravelly soils hold less water. Silty clay soils with a lot of organic matter hold a lot more water so that you don't deal with drought conditions when the hot time of summer does roll around finally. Stoniness, that's huge because it affects the cost, the suitability, a lot of things basically. Clearing stones can be a big cost. And you don't necessarily do it once. And unfortunately, with the nature of our soils being sitting on glacial till for the most part, due to our frost and our texture types of soils, almost every year, if you clear a field of stones and boulders and everything, every year almost you're going to get more pushing up from down deeper, basically due to frost action. The surface warms up, the sun is hitting it, it's thawing out. Down below is just still pretty cold. It just follows the path of least resistance, and frost ends up pushing some of these stones and coarse fragments back up to the surface. So it's not just a one-time thing. The bulk of what you can clear is going to be done in a one-time pass, but every year you're probably going to get some more stuff poking its head up through the soil surface, basically. Bedrock large boulders, pretty explanatory. You're not going to farm on bedrock, and if there's a ton of large boulders, it's probably not going to be economical to clear that ground. And if they are there, then probably got very shallow, stony soil as well. Slope, I already mentioned 15% or less typically is what we'll mine or farm on. When it comes to hay fields and pastures and stuff, you can be greater than 15%. And when it comes to machinery, if you've got a long, continuous slope, even up to almost 30%, sometimes if you go up and down the slope and not side hill, go across the slope, we have areas in the province that are being used for forages and that type of thing with up to 30% slopes, but they have to have a long, continuous slope that a machine can run straight up and down, not sideways. So 15% is just a rule of thumb, but there are exceptions and there are cases where we can use so much steeper ground if the soil and other conditions are good. So how we determine soil suitability? That picture says it all for a big part of it. That's basically what we do. We go out in the field, we dig the equivalent of fence post holes, sometimes 100 a day, over a 100-acre parcel of land, and we map it and we use GIS and we take data loggers and make a bunch of notes. and maps and save a bunch of data, take photos, and that's what we will create our soil maps and our reports from. And we look at all the criteria that I mentioned earlier. Landforms, that's a great way, a very, very, very preliminary way to determine if a site has potential suitability. Certain very complex topography landscapes aren't indicative to slopes. Steep slopes, we know right away. If something is really complex and all over the place, typically it's a bedrock with a veneer of soil over it. So surface expressions and landforms are what we look for. Much of Newfoundland is done on small hills and linear ridges, basically that are fairly smooth to look at. They're not all convoluted and sharp changes in slope and all that sort of stuff. So it's one of our preliminary things that we look at for determining a potential area. And this picture, I know it just looks fairly simple, but it says a lot actually. I was saying before that basically some of our better soils are found up on our crests of a hill and our upper slopes. As we get down lower, we tend to get into a lot more of the coarse fragments accumulated down low. Drainage tends to be lower. Soil formation was slower. We got thinner soils, more stony soils, and less nutrition, less fertility. And it's kind of, a lot of people would think, everything flows downhill. It must be better down here. But unfortunately, most of Newfoundland and Labrador, it isn't the case. It's mostly the mid slopes, upper, and the crests where we find all our stuff. And typically, the crest up here is where we would get our Cochrane soil with really good drainage. This area, mid slope and upper, would be our Pooch Cove 1. As we get down to this lower slope is our Pooch Cove 2s, which are usually poorly drained and have water for a significant portion of the year. And then our flats and any depressions is where our Torbay soils would be located and where they're basically saturated all year round. They're a gray, puggy, very poor, extremely stony soil. And usually they're not worth draining because it just economically, they're just take too much to put them into production. And with today's new farming and regenerative things that we're doing, we want to maintain natural drainage areas anyway to let them do what they're supposed to do. This is just a page. It's in our data dictionary that we use, our soil Bible, we'll call it, that we use for determine all different suitabilities for different crops on different types of landscapes. I'm not going to get too far into it. I just wanted to give a quick introduction to our nomenclature that we use on our mapping. If any of you are interested, you're going to be seeing our mapping and you'll be seeing these sort of stuff. We basically class our ground as good, medium, poor, or unsuitable. And we just put a letter to that: A1, A2, A3. A1 is really good. A3 is, poor. Unsuitable is unsuitable. Basically, you're not going to be able to use it for the most part. So we got these criteria basically that we go by. I'm just going to go through one of them sort of with a little bit of detail. The rest I'll just sort of skim through. So basically what we're looking at is the depth of the roots, how much moisture is, what kind of moisture can we expect the soil to have, what kind of drainage, what's the topography, the soils, the slope, I mean. And you see in here, we've got less than 100 or greater than 100. That should be meters, not centimeters. There's a typo. Basically, if you got a 100-meter slope greater than 15%, you can probably run machinery on that straight up and down. That's why that's in here, basically. The percentage of rock outcrops, large boulders, how much stones and boulders, how much gravel and cobble, and those things. As you can see, depending on the amounts of each of these, it gives us a suitability for the area, and it allows us to know what crops are suited for a certain type of soil type. So I won't go through all of them. I'll just quickly show. We have them for basically most of our crops, cole crops, which are your cauliflowers, broccoli, cabbage, all that sort of stuff. Rutabagas, turnips, there's sort of different suitability. Potato suitability. Potatoes separate from other vegetables for one main reason, basically, is that what's a potato shaped like? Kind of like your fist. And cobble in the ground is shaped just like your fist. If you're mechanically harvesting, the cobble amount in an area for growing potatoes is very important because they'll be taken up by the mechanical harvesters, just like the potato would. So potato is kind of at its own sort of little suitability, and it's the amount of cobble which has a big part to play in potato suitability on ground. And carrot suitability, this would basically be some of our best soil in the province, our sandy, well-drained, sandy loam soils, because carrots need deep soils with not a lot of resistance to permeability to be able to grow properly. You've all seen crazy carrots that are all forked and twisted and go sideways, and that's basically due to a lot of our soil type and gravels and pH texture differences, all that sort of stuff. So that's where I was mentioning that sort of some of the bogland could come into play for growing certain types of these vegetables where you don't have to worry so much about gravel and resistance to the root penetration. Soil surveys and soil assessments are a big part of what we do. We've been doing them for maybe 60 years, and we have a big resource of soil information in the province in a generalized way for the most part. We have a lot of detailed stuff for certain small areas, and if you were to make an application, you would get a detailed soil assessment done on your application area, and we would know every acre basically gets checked and tells you, a map will be made to show you what's good, what's not, what you can do. And the soil survey works for a lot of stuff. It's not just agriculture. Like I say, engineering, for soil management, for construction, mines and energy. It all comes into play for town planners, for management. It's important for a lot of stuff, not just agriculture. And basically, we've got quite a number through the province, and I just basically put a little link down below here, and that's all available on our government website. And basically, you can go in and look at all these different what soil surveys we have throughout the province and get a kind of general idea of where decent soils can be found. This is just a quick example of one of the suitability maps. If you put an application in the Crown Lands, this is a quick example of what you would basically get back. We go through and we delineate all the landscape features, and we go do a field inspection on the ground, and we'll note any wetlands, waterways, old road accesses, trails, and suitable areas, pretty much everything. So we give you the suitable areas based on a certain type of crop. I believe this one's for coal crop suitability down around the Markland area. And it was just a quick indication of what you can expect to find from our mapping and what you can use. And the different shades of green, there's 3 of them. We'll refer to A1, A2, A3, and that'll be good, medium, or poor. Unfortunately, a lot of Newfoundland has medium or poor. The really good stuff is pretty rare. So with soil mapping and capability, there's a lot of different resources in the province. I've mentioned a number of them. The personnel and the staff are a huge resource that you should avail of, but there's a lot of stuff on our website and online that you can also avail of. Soil capabilities are done all across Canada, and they basically just are a very generic, broad spectrum showing where you could probably find some suitable land. It's just sort of a very first base starting point, and they're very generalized and whatnot, but it's a good way to start. And it goes through 7 classes of soil capability. Typically in Newfoundland, we start at I think 4 or 3 because it's based on climate. We just don't have the climate for the first 2 or 3 classes, which would be really good. You'd probably find in southern Ontario and probably parts of southern British Columbia. And you can go through all that and have a look on the website. I won't get too much into it right now. And this is basically the type of map you would see. This is the Northern Avalon Peninsula, just a quick example. You'll see just a few colors, very, very vast amounts of areas are covered by these. And it just gives you a good general idea of where, you could find something to do what you wanted to do. After that, then you would get down to a more detailed level. So this is just a quick example of where a lot of the information can be found. Some of it's on Agriculture Canada, others of it is on our Government of Newfoundland and Labrador website. I just won't go a whole lot into it, but it basically covers off most of what you would want to know about land, obtaining land, crown lands, all that sort of stuff. We're going to do a brief on coarse fragments in geology because you know, it's just our province is extremely stony, and coarse fragments is something you're always going to have to deal with. Sometimes in one pass, and sometimes it can be a prevalent thing that keeps coming back year after year. I went through the coarse fragment stuff. I won't get too much into that again. Basically, gravels up to the size of your thumb, cobbles up to the size of your fist, stones are up to the size of a basketball, boulders are from 2 feet to 10 feet, and the rest is bedrock. This is just a quick little diagram to show the scale of the soil particles, the sizes. So, you know, one particle of sand versus a particle of silt to a particle of clay. That's why clay is basically microscopic. So it's just a good little visual to see, to show the differences between the particle sizes in soil. And this is a very generic show. It doesn't have stones in there, but that's fine. Pebble is kind of similar to, is in between gravel and cobble. And these were the sizes, which I've just stated, the numbers here. Doing the visual like I described it is a much easier way to kind of remember it. Size of your thumb, size of your fist, size of a basketball. That's a way easier way to remember it and to explain it. To determine the coverage of your coarse fragments, we've got these sort of visual estimate guides that we use. So we'll go out and we'll use this or a square. You can make a 10 by 10 foot, 10 by 10 meter little plot, estimate how much is in that, and then you can use that as a sample for your whole parcel of land, basically. And that's basically what we do. And we will determine if it's mostly just stuff on the surface or if it's all down through the soil profile. And we'll make a determination on that. A couple of examples here, stuff that we've seen. The first one is that could be almost anywhere here in Newfoundland. When you see trees blown down, blow down trees are a good resource for doing soil assessment work because you can get a good idea of the coarse fragment content underneath the soil that normally you can't stand, or ATV trails that have run and broken down the organic layer. It gives you a good idea of how much coarse fragments are in a particular site. B is a burn area in Labrador, as you can see. There's excessive boulders. We've got places in the island and Labrador that are, I've seen some like this and worse than this. Typically, when you get into heavy boulder areas, they are usually associated with a lot of coarse fragments down in the profile as well. And a lot of these typically won't be suitable, or they'll be just too expensive to develop to be economical, and they'll be deemed unsuitable. Just a basic geology. Online, you can go 3 main types of rocks: igneous, metamorphic, sedimentary. It makes a big difference what type of basic bedrock you're sitting on, because your soil is kind of formed from that bedrock. So if you know a little bit about your bedrock geology and your superficial geology, stuff closer to the surface, it's just another tool in the toolbox to help you determine your soil and hence your management practices on that type of soil. This is all available on government websites, probably through Mines and Energy, geology maps. This is a very generalized geology map of all of Newfoundland. As you can see, the whole Avalon and the eastern section is all just one basic type. That's not really the case, but just to know that it's just sort of generalized. This one is just the same, just showing some of the major fault lines. Yes, Newfoundland does have a number of fault lines going through them, and that's where a lot of our mining and the new gold rush has kind of been occurring in Newfoundland. We've had tens of thousands of new claims and stuff go in on a number of these fault line areas. So this is just a quick little geology of the Avalon. As you can see from the generalized one, it's a little more complex, and it gives you a little idea, but it's a good resource for knowing what type you have underneath your feet. And then you can know what to do with what type of soil to expect. Basically, for me, when I'm going somewhere to a new area I haven't been, the first thing I'll look at is this bedrock and the superficial geology stuff. That gives me a bit of an idea what to expect when I'm looking for a soil type when I get to an area. And we have it for Labrador, for Newfoundland, pretty much Canada wide. You can find all this information. So we've got bedrock geology and superficial geology. Basically, the main difference there is the bedrock geology is the bedrock basement bedrock that's sitting there. Superficial geology refers to what's, up in the upper surface, maybe the top 10, 20 feet, and it takes into account glaciation moving a lot of material around. So basically, a lot of this stuff would call a glacial till veneer. By veneer, I mean just a little thin layer over rock or over something else. A lot of our province is rock or veneer over rock, unfortunately. So that's why I just wanted to show the difference between the two. One's basically your basement bedrock geology. The other is superficial, and it takes into account glaciation and various different modes of deposition of materials. So the superficial one is probably the more important one to be aware of and to use when you're going out in the field. This is another sample suitability map. It's up in the Northwest River, Goose Bay, Labrador. Typically, that was a large glacial fluvial / marine sand and gravel deposits. And we've got some really good agricultural land there. A lot of Labrador is unsuitable because it's barrens and bedrock. Newfoundland has quite a bit, but Labrador much more as well. And climate has a big part to play with a lot of the soils in Labrador. But typically, the Happy Valley Goose Bay region is a very large sand deposit, and it has some very good soils and has been increasing in agriculture production every year for a number of years now, and is probably going to continue to grow. And this is just a quick little showing a little bit bigger the suitability legend, not to get too involved with it. Basically, it was for coal crops and whatnot. Eco zones, I already mentioned, we're in the boreal forest zone. We have mostly ericaceous material and evergreens. They make our soils pretty acidic, and that's basically the bulk to take from this one. And all this stuff, sort of land cover, vegetation. There's a lot of different resources out there to find what you have in a certain area. If you live on the south coast of Newfoundland, you're typically into a lot of barrens and heathland. If you're in central Newfoundland, you're into a lot of forest, both coniferous, deciduous, all that sort of thing basically comes into play there. It's just a quick little reference and just to show you that there's this information is out there. Temperature and precipitation, as you can see, we get quite a lot of precipitation in our area, the Atlantic provinces, Newfoundland and Labrador in general. And in the second side, just is showing you the heat and basically the mean temperature. And as you can see, a large portion of Newfoundland is just doesn't get the climate basically to produce much in the way of agricultural crops until you get down to sort of the southern part and around the Goose Bay area as well. And you get to Newfoundland, it shows you a little more on the temperature side of things, to average temperatures. It's just a quick example showing you stuff up around Happy Valley, Goose Bay. Any of you have been down around Terra Nova Village, down what they call the Thunderdome? It's a great big area of all sand deposits that were basically deposited by glacier or by marine, and it's very similar to that. It's a lot of sand. You get really good drainage, and you can get some good, deep, sandy loam soils on these sites that are very good for agriculture. Unfortunately, we only have a very small amount of this in the province. Just another example, just showing something, road cuts, doing digging. Sand is very prevalent, and you can get some pretty deep topsoil layers on this as well. I just thought that was pretty funny to see and to show that I guess you can do agriculture just about anywhere. And sometimes you can get caught between a rock and a hard place. I'm going to go through soil erosion a little bit here because that's a big part of what we're facing these days and what in Newfoundland. Water control and soil erosion, basically. Water management is one of the biggest things you'll face on your farm when you're going doing land. So basically, three ways erosion occurs: through tillage, water, and wind. Wind, not so much here in our province, but water, definitely. And erosion is just, it's pretty straightforward. Movement of material from one place to another, typically from higher slopes down to a lower slope. Very severe on steeper slopes, and exposed bare soil is very prone to erosion in Newfoundland. Some areas much worse than others. There are places in the province where even on very low slope, if you leave an area unvegetated for one season, you can get significant erosion occurring. So erosion, like I say, erosion's not good. It removes your soil, takes organic matter, nutrients, and can introduce pollutants and things into waterways downslope. For fertility, it'll be reduced. Everything can be impacted basically. So managing your water is one of the most important aspects of farming in our province, basically. And like I say, the economic and environmental costs are huge if it occurs to you and to the world in general. Quickly, just give a quick skim of the types of erosion. There's four main types, basically, or four. So we've got basically rainfall, raindrop erosion. If you have bare soil, if you're watching when it rains hard, you'll see soil hit. It makes a little divot, almost like a mini crater, and it pushes all the soil away from it in a little circular function. You expand that, and it gets pretty significant, and it'll turn into all the other types of erosion. So interrill raindrop erosion is basically what I just stated. Basically, as a drop falls, makes a depression, spreads the material aside. Potholes in a road are very similar process. Basically, as your tire hits it, the water spews, causes the particles to be thrown out, and then that hole will just get deeper and deeper and deeper over time. Sheet erosion, it's if you have a field left bare with nothing on it and it rains and you get excessive rain, it's just going to run off and it's going to cause all different kinds of erosion, taking your soil with it, which is very valuable. It's an example of here in Newfoundland, a very low slope. And you can see in the center channel here, it was maybe 8% slope or something here, and it still eroded this and brought it all down here. So it doesn't have to be super steep. It just needs to be, you need to know your soil type and texture to be able to manage your soil properly, especially when it comes to water management and water controls. Real erosion is basically the beginning of what happens. Water will find the lowest point. It'll pool in that point, and as water accelerates, it gets more energy, it picks up more material, and it will erode more and more and more as it goes. This was a site in the province, basically, that was he'd farmed. It was almost 9 to 15% slope. He rough cleared it, left it for 2 years. This is the result of what happened. So if you leave soil bare, you don't use it, basically it can get destroyed, ruined. I've gone back recently and looked at it, and we can't even really remediate this site. It's been damaged so much that it would be cost way more than what it would ever be worth to try and remediate this site because someone didn't follow best management practices. Gully erosion is sort of the fourth and biggest that we'll end up seeing. You've all probably seen some of this, and even mass wasting and landslides are, a form of gully erosion. This is almost that same site, and as you can see, it just pretty much got destroyed. Most of the soil got washed down, and it's just a horrible place right now. We can't do anything with it, unfortunately. At the very first, when it was cleared, it would have been quite a nice site for actually growing a number of crops. This is another example, gully erosion on a low slope. Once water gets going and a certain soil texture and type, water just destroys it. Stream and channel erosion. We've all seen these rivers, riverbanks giving in, flooding, compaction and ruts from vehicles and trucks and everything else. That's a huge thing. You'll see that very prevalent here. Due to our short growing season, everyone tries to get on their land early when it's still wet, and they'll work it late in the fall when it gets saturated. And this is the result, basically, what you will get. And it's way easier to try and not create it than it is to try and fix it. Once again, shines a compaction on fields, and that results in impermeable soils and poor root penetration, all kinds of problems. This is what you would see in a profile, typically over here, all this rusty colored looking stuff. That's basically, there's water saturated that for a good portion of the year for that to be happening. And this here just shows a hole in a poorly drained area. It's all this rusty mottled color, grayish color, and it filled with water. So soil drainage classes, won't get into that. We go from moderately well to very poor, and there's a bunch in between, kind of direct relation to position in the landscape and slope as well. This, I won't worry so much, just wanted to show just the positions in the landscape and how slumping and water and various erosion things can happen on different forms of landscape. Erosion controls, quite a few of those. Um, I'll just quickly go through these because it's something that if you get into it, when you're actually get a farm and whatnot, we can really go into a lot more. Typically for splash erosion or the raindrop erosion, you want to keep your ground covered, keep vegetation on it, especially if there's any type of slope to it. Flatter ground is a little easier to manage, but when you get sort of a slope to it and a very heavy textured, fine particle size soil, erosion is really, really prone. The same thing with sheet erosion. Bare soil is bad. You want to keep something on it, some type of cover crop. The remnants of your residue from your previous year's crop, the roots, or plant something that will keep the roots will help keep that soil in place. Real erosion, basically same thing. You just need to sort of know your land, know your soil, and find out maintain your natural drainage areas. Like sometimes there's just these little depressional areas. You won't see any water in them right now or anything, but water will always go to the lowest point. And these natural drainage dips, drainage channels, if you can maintain those, great. And if you have to do something when you're clearing your land, it would be best to revegetate those as quickly as possible. There's a bunch of different, mechanical methods you can use, but you want to try not to have to get into those. But if you do have to use them, they're there to do. A whole bunch of different controls here. I'm going to go through a few diagrams real quick on them. And basically, the picture is worth 1,000 words. So these are barriers or just slow down water flow. And you've probably seen a lot of this. Many of you, if you've driven up the Guju Highway from Pennywell Road, you'll see where they did the rock cut through all the blast. They have numerous piles of rock piled in the ditches every 20, 30 meters. And that's to slow down water velocity so it doesn't erode out the banks and everything around them. So this is pretty typical, just a rock French drain. And these are just barriers and slowdowns. Basically here as well, you put in stuff that's highly erodible, you put in these dissipators and it slows down your water flow. Contour farming, that's when you're on slopes of a significant type. Basically, you want to go with the contours. Instead of going traditionally, we've gone up and down the slope and we'll plant our crops up and down, like this up and down. You follow the contours and you make your beds, leaving little areas of unplanted areas or just with grass, and they capture the water. It helps to prevent erosion and keeps your crops with a decent water supply throughout the year. This is a very good visual to show basically. So we don't want to plant crops up and down the hill. We go with the contours. It just acts a lot more naturally. You keep your nutrition, you'll keep your moisture, you'll help prevent erosion. And it just, when it comes to the carbon side of things and everything else, just also plays a big part in it. Geotextiles and synthetic stuff and brush mats, all this kind of stuff you've seen during construction. Not overly prevalent in agricultural use, but can be. It's just another tool in the toolbox. Silt fences and geotextiles. You've all seen these. Anywhere there's construction going on, you've seen these. If you're doing your construction, you're building a road or clearing a field and it kind of gets pretty wet out, there's a pond or a river or stream below you, it doesn't hurt to set these up down at the peripheral and your riparian areas and whatnot to keep any sedimentation, any stuff from flowing into the waterways during the initial construction of your roads or your fields. And once again, similar. And vegetation is one of your biggest assets to use for erosion, water controls, and everything else, basically. You've all seen hydro seeding, whether it's on a lawn or on new roads when they're constructed, steep banks and areas that are highly erodible. Swales or depressions you can seed to help keep them from eroding, or slopes or hillsides also. Vegetation, I just wanted a quick show. The big thing to take from this is just showing mowed grass versus native vegetation and herbs and shrubs. Mowed grass doesn't go very deep with its root system, versus all this other stuff, native plants and vegetation, is a much better system to use in your riparian areas or any other areas you're not going to really farm and want to protect and maintain the soil on and prevent erosion. And that's just what this statement is showing here. Native plants, they're, developed for our climate, they're developed for our soil types. Use those basically in riparian zones and buffer areas. I mentioned swales, little low points that don't necessarily show water flow unless it's excessive amounts of water. And that's what these greener areas were. They were vegetated with some type of grass. There were drainage swales just so they wouldn't erode and wouldn't go. And like I said, with certain soil types, even on really low slopes, you will experience erosion. Cheap, efficient ways of doing it, hay bales, and different ways of bundling up these hay bales. They got a bunch of different names on them. I won't worry too much about them. We just tend to call them bunds or hay bales. And they're very inexpensive and very easy to use. Something that you can pretty much get almost anywhere. And we've all probably seen instances of hay bales in conjunction with the geotextile fabrics, the silt fencing. Use those. Just another example. Retaining walls, gambions, that's pretty straightforward. We've all seen those as well. They can get a little more expensive than the hay bales and whatnot, but in certain cases, this is what's required. Armor stone or riprap, whatever you want to call it. It's basically the same thing. This is a before and after example of using gambions and riprap, armor stone, completely eroding away, and now it's all secured and kept in one place. When you're doing your roads and that sort of thing, where your culvert outflows are and things, it would be good to armor stone those. If not, when you get these severe rain events, basically undermine all this and wash out and can go back and take out your road on you. So any outflows of your culverts is a good idea because you're going to have plenty of rock from clearing your fields. Just another quick example. French drains, very cheap, very efficient. They do the job, and 9 times out of 10, when you're doing your land clearing, you're going to end up with substantial amounts of coarse fragments. Why not use them for something? It's a cheap, inexpensive way to do it, and you can backfill those, put a geofabric over them, soil back over, and not have loss of part of your field and still have good drainage. Interception and drainage ditches. Many fields and farm areas in our province use these basically. They'll take up on the upper slope, if there's a lot of seepage coming into their area, they'll do an upper slope interception ditch, do drainage ditches down the side, and at the lower end have an interception ditch and channel that water away to a proper drainage area. There's most areas you'll see in Newfoundland all use these. And this is also another method as well. A little more expensive, a little more intensive, a little more time consuming, but is also definitely an option for getting decent drainage in your field. And this is basically what you would look like. And the right is an example of a field without any drainage. Once the tile drainage goes in, it's taking the water away, not allowing it to pool up. So there's a lot of different ways to manage your water, and this is just a couple examples of them. That basically covers off the second module. I know it's a lot to take in. I've been speaking quite a lot and probably went through stuff fairly quick, but most of it is just to give you guys an introduction to all the different aspects that you're going to have to consider and all the different methodologies and the people and resources out there that could assist you with all this stuff. I figured it'd be a little funny to throw a bulldozer there because that's probably the guts of the whole presentation, basically, is the heavy equipment part of it. All right, we'll get started on the module 3, and it's basically land clearing practices and standards in the province of Newfoundland and Labrador. We'll get right to it. So basically, we have a set of land clearing standards, which we can find at the following website, which is on our government website as well. We have a couple of different documents, and there's quite a few videos and stuff online as well that you can look at. So basically what it comes to is we've got sort of best management practices that we like to follow, whether it's initial land clearing, initial production, continuation of your fields, all that sort of stuff. We've got a lot of different management practices that should be followed, for the best, for you to be successful economical and to avoid degradation of your land base that you have. Um, so basically, first, what you need is you got to have a piece of land, and you have to have clear title to that land, whether it's lease, private land, whatever it may be. You need to have the land. And the second thing you have to do before you put a shovel in the ground or a blade or a piece of equipment is make a plan. You need to know your piece of ground. So you want to walk it, you want to take a look at it, use what mapping you have available. You can use a drone, you can have satellite imagery, whatever it may be, or suitability maps. But basically, that's what you need to do. And then you need to make sure that it's a suitable piece of land for agriculture. I know a lot of people that have tried to clear land and tried to put it into production. They didn't go through us. They didn't really know quite what they were doing to start with, and they just tried and tried. And you can spend a ton of money, a ton of time, a ton of resources, and you still won't be successful. So these steps are pretty important to follow, and finding suitable land is critical. One thing that you have to do. So once you have your piece of land, it's deemed suitable for agricultural use. What do you do next? So basically, we've got our best management practices, and if you're unfamiliar with heavy equipment or land clearing, agricultural land clearing is very different from what you'll see for most other land clearing. People that are doing construction or mining or any of that, basically they want to get rid of the organic and that B horizon topsoil off of it before they go do any construction or anything else. We're the opposite. We just want to get the vegetative surface off. We want to maintain as much of that organic matter and that topsoil as possible. So this is basically going to describe the best way to go about doing that. Um, So like I'm saying here, here's just a few kind of basic considerations, which I mentioned before. 15% is kind of our magic number that we'll use for land to be considered. You can go up to 30 in certain instances, but they're sort of site-specific cases. And usually when you've got long, continuous slopes that you can go up and down with machinery, because very little agriculture in the province is done by hand or hand tools anymore, except for home gardens or something like that. We always got to have the equipment and tractors and stuff, going around, whether you're clearing your rocks, you're seeding your crop, you're harvesting your crop, you're spreading lime, you're spreading fertilizer. You're going to be doing a lot of time passing over your land. So slope is important, and season. If it's saturated, you definitely want to stay away from it. Um, so we've got to be, that's why the slopes is important. We've had a number of accidents over the years with tractors tipping over and certain things, and we just don't want that to happen. We want you to be safe as well as successful. So basically, you want to get most of the organic stuff. By that, I mean the vegetation, trees, brush, timber, any other undesirables removed, and not remove as little topsoil as possible. Your boulder stones get removed. And when it comes to windrows, you don't want to push this stuff for long, long distances. You want to keep it within a certain distance, basically, to keep economical and to not really compact and destroy some of your land before you ever get it put into productions. When it comes to waterways, ponds, lakes, streams, that sort of stuff in the province, we typically maintain a minimum 30-meter buffer from these natural water courses. And that would mean don't clear the vegetation. If necessary, set up sedimentation control and with silt fences or hay bales, something like that, so that your stuff where you're working on the land is not going to flow into that. When it comes to protected water supplies or salmon-bearing rivers, the buffers can be quite significant, up to 270, 300 meters at times for some of these. And some of them you just can't go in at all, especially when it comes to some of these protected water supplies. And if you do go in, there's a whole bunch of things that you'd have to consider and practices you'd have to follow. So there's a whole bunch of stuff, like I said, predominantly in Newfoundland, forested areas are what land is cleared for putting into agricultural production. Occasionally, you'll hit, now these forested areas can come in three different forms. They can be mature forest, that, commercial timber, all that sort of stuff. If you're clearing this, then typically you'll need a commercial cutting permit from Department of Forestry and someone to go and cut it, whether you cut it yourself, a commercial harvester or domestic cutters go in and do it. but it's going to have to be done, and then you have to follow the conditions set in that permit by forestry. You report how much you cut. There's a small, probably stumpage fee to pay or something like that along the lines. If you've hit a area that was, harvested in the past, or it's been partially cut over, or it's all sort of smaller wood, not merchantable timber, that's when you get into this sort of forested, non-merchantable stuff, and you don't necessarily have to harvest anything. You can just sort of knock it down and push it to the side with bulldozers and tractors and that type of stuff. So there's a bit of a talk through right here. I'll have a whole bunch of images with the machinery doing these processes in the next few slides. I just wanted to give a quick lowdown on the types of ground you can expect to encounter and methods of clearing. Typically, any agricultural land clearing equipment, their blades or buckets or whatever, are like basically like a sieve. They're not solid, they have holes in them. So basically, as they're hauling up these stones or boulders or roots or whatever, all the soil can fall back out onto the ground, and you're not taking it and putting it into your windrows. So the one method, like they say, is a walk down and pile. I won't get too much into it with the text side here. When we get to the pictures, I'll describe it a little better. Um, Doing it during dry conditions. The harvesting can be done in the winter. A lot of people do in the winter. They'll do their harvesting because they can use skidoos, sleds, ATVs, whatever, harvest machines, all that sort of stuff. You do not want to clear land when it is wet, early in the spring, late in the fall, or after a heavy, intense rainfall. If you get on the soil when it's wet, you're going to do all kinds of damage. You're going to compact it. You're going to create ruts. You're going to have erosion problems. Your structure is going to be destroyed. Trafficability is ruined. Your soil permeability, everything is just ruined basically before you even start with a crop. So I've seen A1 land, which is pretty rare in the province, and use the wrong equipment and wrong techniques, and they degrade it to A3 to almost unsuitable just in the rough clearing phase. So land clearing, knowing your soil, and don't do it when it's wet. Unfortunately, in Newfoundland, with our short season, people push it. They get out too early in the spring, they get out too late in the fall. And sometimes it's a matter of economics. You just don't really have a choice. You kind of got to, and you take the small, degradation that you suffer from it. But that's just the way it is here sometimes. Newfoundland's a tough place to farm due to soil type and climate. It's pretty tough here to do farming, and we try to minimize this, but it does happen. But if you can, don't do it when it's wet. So cut over areas, they're pretty easy. You don't have any merchantable timber to worry about. You don't have a whole lot of stems sticking up. You got probably slash piles and some stumps to remove. So it gets a little easier. And this is just noting just some criteria basically and methods that you do basically when you're doing it. And all these have what we call rake blades. So they're blades with holes in them, like a screen basically. So all the soil can fall out while you're pushing everything else in. Light vegetation areas, that could probably be somewhere that burned, somewhere that's heath sort of barrens with just ericaceous, knee-high shrubs type stuff or whatever. A lot of that, you don't want to use a bulldozer or whatnot to do it because you're going to end up taking these native plants tend to have pretty deep roots, and you'll end up pulling a lot of the soil along with it. So basically, you can use braking discs, rotary tillers, mowers, something like that to basically mulch it all up, and then that can kind of get incorporated back into your soil, which is only good in the long run because it adds organic matter. It'll also probably add some rough, coarse fragments, which will help with your drainage and trafficability. We've got a lot of contractors in the province that do this sort of stuff. They specifically do mostly agricultural land clearing, and some of our bigger farmers in the province also contract out as land clearing and stuff to help out. And they are some of the best that you can get your hands on. A good operator is worth his weight in topsoil, basically, because a bad operator, as I mentioned, will degrade and ruin a site before it's ever put into production, just in the rough clearing phase. So the right contractor is critical. If you're unsure, or you got equipment, you're not familiar with it, you're not very experienced, it's sometimes worth it to go to an outside contractor, even if it's just for advice, even if not for the total clearing of your land. With your windrows, where you're going to pile this stuff up to, you don't want to mix your coarse fragments with your organic stuff, your vegetation, your trees, plants, stumps. You want to kind of have in separate piles. All your stones you want to kind of have elsewhere, because these vegetation piles, they're going to rot and degrade over time, and that's something that you can take and screen out and then push back over your fields. And the area where these windrows are stacked is basically taken away from some of your suitable land of your fields. So the windrows and proper positioning, you don't want to have them across the slope. You kind of want to go with the slope on those. So that, unlike contouring where you're with the slope, you almost want to have your windrows perpendicular, so they're not going to be holding up a lot of moisture and drainage and causing ponding and stuff like that on your site. So there's a whole bunch of little things that you have to consider, and you want to keep your soil out of the windrows as much as possible and kept on the ground and in the field. You shouldn't push them into really wet areas. If it's an area that's just sort of unsuitable, low lying, and it's not stream or whatever, has a little bit of moisture now and then, they're okay. But anywhere that's considered a wetland or a stream or ponds or a natural sort of good drainage channel that's going to affect your land or some downhill resources, you don't want to pile this stuff into them. So windrow placement and size and everything is important and good to remember. Like I say, at times your windrow can take up 20-30% of your suitable lands at times, So a suitable land is very at a premium. You want to maximize it as much as possible. Take this stuff after a certain amount of time and push it. Back in the day, slash burning and burning windrows and everything was, one of the main practices of getting rid of this material. But with our carbon sequestration and all this sort of stuff and global warming now, typically burning isn't done very often. It's mostly the material is left to decay and on its own, and then it can be taken and pushed back over the fields. Occasionally burning does come into play when you're doing probably rough clearing for slash piles or something like that in the fall. But typically burning isn't used a whole lot anymore because that's a big massive input of carbon into the atmosphere quickly. So that's another reason why we're trying to move away from that. And that bottom part can't stress that enough. Good operator makes all the difference on getting your land cleared and keeping it. Sometimes you might only have 6 inches to a foot of decent topsoil. If you get a wrong operator in there, he takes half of that and puts it in windrows or off. You basically ruin that site, and it's very, very hard to remediate it or try and find another place. This is a quick little view of an area showing basically in our windrows about 150 meters apart roughly, and it just gets more economical and just for our best management practices to do it in this way. And as you can see, they're perpendicular to the slope. The slope is going this way, up and down the hill. This is also the place where I showed those pictures of the gully erosion and the assessment going on here. These fields over here were left vegetated or grassed. These ones over here were left bare. These got ruined and destroyed. These actually over here are still actually suitable and can be put into production. So bare soil is bad for a lot of places, especially if you're leaving it over winter. Permitting and legislation, there's quite a bit to those, but typically our agricultural development officers or agri-food staff will give you the lowdown on a lot of these, and we can basically help you out and show you what you need. Worst to worst municipalities. So with federal, it's not really big. It's just stuff bearing with regards to salmon bearing waters and watersheds. In the province, we have a number of different things that we kind of need to look at sometimes. Commercial cutting permits. Operating permit is just if you're working equipment during fire season. You're building a road, you might need a road plan. If you're in a protected water supply, you'll need certain documents. There's environmental assessments. If you go over 50 hectares in size on your initial parcel of land, an environmental assessment's automatically triggered, and that can delay your process. There's more work has to go in, more checks have to be done, and more balances and whatnot. And then, like I say, wetland and streamland buffers. Municipalities, towns, and cities, they may have their own stuff they want to see, a development permit when you're clearing land or putting in a road, structure permits for building a barn or a garage or a cold storage road, and sedimentation controls. These are just generic sort of ones I've put out there. There may be some more to it, but typically as you get going, you'll get these figured out pretty quick with our help and with talking to the town or municipality that you're in. And this is just on our website. All this information can be found on the government webpage as well. Under agriculture and lands legislation, there's a number of different acts and permitting and legislation and policy with it all that you can go through. Typically, we help you out with a lot of that stuff too when you're getting started up. Making a plan. I mentioned that before. Land clearing plan is critical because you want to know what you have before you get going, so you don't destroy stuff, you don't ruin wet areas and all this kind. There's many reasons, economically, environmentally, a lot of reasons to make a plan first. Walk your ground, walk your land, make some notes, figure out where it's good, where it's not, where you want to do this, where do your barns want to go, where's your road want to be, where's you going to put your vegetables, where's your pasture going to be if you got livestock. All that stuff is very important. Making a plan just saves you time, money, and headaches in the long run. And that's basically what I'm saying here. While you're doing your plan, grab some soil samples. That'll help you out too in the long run. Soil samples are relatively simple to get. They're about $10.35 to get processed here at our lab, and it gives you a full workup of your pH, your nutrition, your organic matter. And if you tell us what crop you want to grow, we can tell you exactly what you need to add to that soil to get optimum crop growth. So sampling and planning, it's very critical when you're starting up. And this is just another sample suitability map of an area that we have locally, and we've gone through, and you can see we've mapped out roads, waterways, leases, and what's suitable and what's not. And all those little dots are places where I've actually been and dug holes and taken notes and taken pictures and everything else. So we basically cover off all the parcel of land that you're interested in and can tell you what's good, what's not, and the best way to clear it. So topographic maps can help you with contour lines and slopes and wet waterways and all that sort of stuff. And satellite imagery is a really good tool, whether you get it from online or whether you have a drone and you make your own. It's great basically because it just gives you such a good overview. You can see everything, and it's just, like I said, a picture's worth 1,000 words. And that's just a close-up of a quick little piece right here. The guy's clearing some land. You can see in here, he's got a wet area. He's got a ditch dug to drain it out and hooking into the wetter areas. Left a couple of parts here were basically bedrock with some vegetation on them that he left behind. So it's just great to have a plan before you go in and do all this stuff. He knew this was here. He knew that. He knew he'd have to do a ditch. So before he started clearing anything down here, he did his ditches to get drainage working, and then he did his work and cleared all the rest of this stuff. And these are just a couple examples of some typical, land clearing plans. They've got their wet area all delineated out with appropriate buffers. These areas are where they've got their sort of going to have rotational pasture and grazing. They've got the windbreaks here for crops that are sort of wind susceptible and cold susceptible. And they've identified all their water bodies, where their buildings are going, where they want to have a little bit of forest left behind. Just everything. It just makes life a lot easier. Take the time and make your plan, and you'll be way more successful, and you'll have a much better land base, basically. Just another quick example showing where your wet areas are, natural drainages, all that sort of stuff. And then your contractor knows when he comes in, okay, there's this. I won't go touch this area, but this area needs intensive clearing and all that. Farmscaping, I guess, is a phrase that's come up lately in agriculture, and it's basically kind of mimicking nature, and ecological engineering, I guess, is another term for it. Making a land plan. It's just utilizing your land to the maximum that you can, and it helps you with a number of things, with maintaining natural pollinators, keeping natural drainage areas vegetated so they don't erode, a whole bunch of stuff like that. Where do you need to keep riparian buffers, and even windbreaks for areas where you could have wind susceptible crops and stuff like that. Different tools that you can use for the landscaping and farmscaping side of it. This will be discussed a lot more in the next modules of regenerative agriculture. But strip cropping, don't clear your whole field. Just clear the strips that you need to plant and leave the rest as a grass or a natural vegetation. Terracing isn't something that's prevalent in our province per se, but many places in the world it is. And as populations grow and our limited land base is taken up, this could become something that is more prevalent even around here in our province. No-till planting, basically they leave the residue and stubble from last year's crop. They just come around in the spring and they have cedars that just strip plant into those areas basically, and your old roots and residue is basically organic matter. It helps to maintain a lot of biological stuff in the soil and helps to really prevent erosion and helps to keep it more trafficable so you're not doing damage when your ground is wet. Windbreaks, I already mentioned those in riparian areas. Contour cropping we've discussed, and cover crops. So that's a big thing that's going to go through, but that's something that is really becoming prevalent, and there's a lot of actually funding and programs in the province right now geared toward this. So we don't want soil left bare in the wet fall and the winter time. So basically, either they plant a cover crop, intercrop when they're planting their initial crop in the spring, or as soon as they crop out their stuff in the fall, they plant a winter cover crop. It helps with a lot of stuff. It helps add organic matter, helps add trafficability to the soil, helps prevent erosion, and helps prevent loss of organic carbon. Agroforestry, sort of fancy word for using trees with your agriculture, so windbreaks or riparian areas, or even where you got pasture land, you want to keep a few little patches of timber for shelter for your animals during the crappy weather and that type of stuff. Contour landscape, I went over this already. I won't spend too much time on it again. It just has a lot of benefits. One or two of the downfalls, I guess, is it's a bit more labor intensive, and you have some areas that you don't have planted with crops, so you're a little bit of land loss. But typically, the benefits I think outweigh the bad part of it. And is just showing, like say, terrace farming is a little different than what contour farming is. It's all flat plateau ledges, whereas this is just going with the slope. You have little ditches dug in between your crop rows, and they catch water, help funnel it down, slow down velocities, prevent erosion, and help keep moisture to your plants for longer parts of the year, especially during the hot time of summer. And typical equipment you're going to use clearing land. This is pretty much all of it. Slightly bigger size, I guess, when you get to the actual fact, but tractors, bulldozers, excavators, dump trucks, they're critical. You can't do much of the land clearing in the province without using this stuff. So I'll go through this stuff fairly quick. A lot of images here. It's just showing you the different stages of clearing. So basically over here, we've got a straight blade bulldozer. All he's doing, as you can see right here, he's just knocking down the trees, the brush, all that sort of stuff. And then this guy's going to come behind on a 90-degree angle with the rake blade and push all that into the windrows. And it's just another example of them doing the walk down, knocking it all down, and then pushing it off. And as you can see, I put a number of different pieces of bulldozer equipment here, just to give you a good view of what these blades are, these rake blades. The curve of the blade is very important as well, because when you're pushing all your debris, it makes it roll, almost like a vertice in water or something like that. It makes it roll, and that helps knock all the topsoil off the plants and off the roots and keep it on your field where you want it. With excavators, they have something similar, and basically they have a rake bucket, rake blade, basically they do. This kind of comes in handy for pulling up your big stumps, getting rid of your bigger stones and your boulders and stuff. You can lift up and they can shake basically most of the topsoil off the roots. And when it comes to water pollution, we've kind of gone over a lot of that in the erosion side here. But basically, it's just to, don't go within 30 meters of waterways, maintain that vegetation buffer. When overland runoff is occurring, use some of these filter fabrics or hay bales to sedimentation control, basically, to keep stuff from getting into waterways from your active construction site. All your fuels and chemicals and all that sort of stuff should be stored and maintained a fair distance away from any water bodies. Typically minimum 100 meters, depending on the slope and whatnot like that. It can be much farther. And if you have any spills or stuff, you should make sure that the contractor or yourself has some type of spill equipment and absorbents and stuff on site for fuel leaks or hydraulic fluids, all that, because that's pretty common for hydraulic fluids to hose to break or something like that when you're doing land clearing. And we've gone through some of these erosion controls, but I just wanted to throw it in here with the land clearing side as well. It's there's a lot of different ways to do it. There's some very inexpensive ways, but it's in some places, towns, municipalities will require you to have a sedimentation control plan before you do any land clearing. We've all probably seen examples of these with ATV trails and logging and all that sort of stuff, corduroy roads. When you're going into an area or you're building a road and it's super wet, you want to kind of don't want your equipment sinking. You don't want everything covered in mud or bog. You don't want to degrade a site. You don't want erosion happening and degrading downhill water resources. So use of brush mats and corduroy road is a great resource, pretty inexpensive and, mildly labor intensive. And you can use them just about anywhere. They can be used on farm once your farm is established or during the construction phase. And these are just some brush mats, just really cheap, efficient ways of getting over wet ground with equipment. With regards to stumps, there's a couple of ways to get rid of them. And one is using bulldozers is not an effective way. Typically, you disturb too much soil, you pull too much soil up with the root wads. This is one way. You can use a stump grinder or stump borers, and they basically just grind the stump down to wood chips, and that can be incorporated back into your soil. And then you don't have to try and pull up these stumps and pull a bunch of soil with them as well. Once you got most of your heavy vegetation done, you can use these disc breakers or tilling machines that will kind of help to, you can make small windrows of your organic debris, your bigger organic debris, and some of your stones and cobble and stuff like that. And then you can come along and pick it all up later. Or it can actually even help break up the smaller vegetation and you can incorporate that back into your soil. And this is basically the similar thing. It does root and rock rakes, and they kind of help, sort of like a rotor tiller to a certain extent. They kind of rototill and they windrow stuff at the same time. If you want to use to keep as much organic matter as possible, you got a lot of all small stuff on your site, not merchantable timber, different mulching attachments or stuff that you can use. You see it a lot around here when they're doing a construction or they're doing right-of-ways for roads or clearing the roads for visibility for moose and stuff on our highways. You see a fair bit of this stuff going on. There's a bunch of different machines that can do it, but just to be aware that they're out there and you can use it for getting your vegetation gone. So once you got your vegetation gone and you're down to your bare stuff, then you get into stone removal. This is the probably bigger phase of land clearing in Newfoundland, and where some of the funding, we have a substantial amount of funding that can go into this because it gets pretty intensive and can be pretty expensive as well to get this done. And a lot of our land, as you see in this picture, is very, very stony and cobbly with all sizes of these coarse fragments. And you can't really use any farm equipment on them. You're just going to break your tilling blades and harvest stuff and everything. You got to get rid of this stuff. So this is basically the way to do it. Just showing this area is in the process of being cleared. Some of the stuff's been windrowed. Another machine will come along and pick it up. And this was out just near Paddy's Pond, an area newly cleared this year. And you can see in the windrows in the back, they've got their bigger stuff pretty much already picked out. Now they've got less sort of stone and cobble or smaller stuff that they've got to get out. Stone clearing is typically a 2 or 3 pass maneuver. Can't typically get it all done in one go. Some equipment can do it, but most of it you can't. You got to get rid of your big boulders and stones first before all the other stuff comes in. I just said all this basically. It's bulldozer are okay. You can move boulders with a bulldozer. Sometimes you get boulders that are too big to be moved. So if you can, you dig a hole right next to it, deep enough to just push it into and make sure it's about 1 to 2 feet below the surface when backfilled. So that's an acceptable method of getting rid of some of these big, large boulders. I guess as a worst come to worst, you can probably get a driller blaster to break them up for you and then get rid of them. And there's also other things that you don't need, different epoxies you can drill and put into them to break some of these big boulders and get them out of the way. And this is just some of the sites in the province when we've got sort of rough clearing or cutovers. The left picture is an area that was just rough cleared and still needs to be stone cleared. Hasn't been done yet. You can see it's pretty stony with all different sizes of everything on a half decent slope as well. The right picture just shows some small boulders and stones that were cleared and put in their own separate windrow. And this is a field that's already had one pass. Basically, it was an excessively stony, cobbly area. So he's got the boulders and big stones out, and now he's tried to do a plant in it. You can plant some things in this, but he's going to go and do a second pass with the rock pickers and the different equipment to get rid of the stones and most of the cobble. This is also an area, this is more western Newfoundland, and it wasn't too bad when it came to coarse fragments, but you can still see there's some boulders sticking up and stones and stuff poking around here, and the cobble and stuff will have to be cleared out of it. So for doing that, we've got a lot of different equipment. I know I'm getting close to the time here, but I'll get through it real quick. We've got these precision rock pickers. They're not overly prevalently used in the province, but they are an option to use by hand. That's been the way it's been done for hundreds of years, and it's still being done. I spent a lot of time as a young fella and teenager doing this, picking rocks and on farmers' fields and stuff. So it's still a way to go on a small scale, but economically, it's not done too much anymore. But small scale, you can. Rock reels, these are very common to be used. Basically, a windrower will go around, make these rows of rocks. This guy comes behind, picks them all up, and doesn't take any soil with it in the process. Rock buckets, these can go on a bobcat, excavator, front end loader, and they're also good. They can dig right into the ground, get everything up. They leave all the soil behind. Your smaller gravels are left behind, and they take all the bigger coarse fragments. Rock windrower, that's what you would have used basically before that rock reel came through. Basically, this just takes everything and sends it over to one side. So you got rows, and then you can come along and pick up your material. This is also another example of a rock windrower in action, I think down around the Whitburn area. And these rock rakes are landscape rakes. They can come in all different sizes. You can have them hooked to the back of an ATV. You can have them hooked up to the biggest tractor that you can have, and these can take away a lot of your smaller rocks and cobble and some of the organic branches and fruits and stuff that might be littering your surface. This was how it was done back in the day. Basically, this is what they call a hay rake, but it was also used very commonly for raking out rocks and stuff out of soil as well. So could have been a couple of horses hooked to this, or oxen, old tractors, whatever. But it's always been done, and it's always going to be done. You can't farm with all these coarse fragments in the soil. It's just unproductive, uneconomical, and does too much damage to your equipment. These type are rotovairs, and they're basically this chisel piece here goes down into the ground, sometimes up to a depth of 2 feet. It vibrates in deck. It pulls up all the rocks, twigs, small stumps, takes and throws them in the back. All the soil falls out back on the ground. And they have a dump associated with them, so they fill up, and then you just go dump your rocks in the windrow. They'll be handy for if you got to do any road building, you got wet areas you need to cross, or if you want to dig French drains or anything, these rocks and coarse fragments can be reused in the future. Rotovair is a sort of specialized piece of equipment that's come on the scene in the last 10 years, and it does everything all at once. I think you still need to get rid of your large boulders first by heavy machinery, but then this can go through, works the same way as a chisel tip. You can set the depth. It goes down to 2 feet deep, picks up all the coarse fragments, old roots and stuff like that, puts them in a container, and leaves all your soil behind on the ground. So you can have a container or a conveyor hooked up in a truck picking them up. One other thing is rock rollers. Typically, in Newfoundland, with our soil, our landscape, we don't use these very much. They might get used as profilers for sod farms and that sort of stuff. And once you get ground cleared, or if you seed it in hay, run over with this so the birds aren't going to eat all your seed and stuff like that. Not overly common, but I just wanted to put it in there. We have a thing recently that we've been using and experimenting with in the province is rock crushers. And once you got your large boulders and stones gone, instead of going with the rock pickers, you can go through with these. Now, sedimentary rock is more forgiving than granites and very hard metamorphics and stuff like that. But they can take
a large stone and in a short amount of time crush them. So here's an example. Basically, here's a field that's look at all this cobbles, some stones, gravels, and once it goes over, it's basically leaving behind finer gravels and soil basically from where all those stones were. So you're kind of adding to your soil depth a little. You're keeping some of that nutrition from all these minerals that are in these stones and quartz fragments. And they do a pretty good job. They can be a little expensive and time consuming and probably expensive to replace and repair, but there's contractors here that have these and can do them for you as well. We also have, the province has a leasing program for equipment, and there's 3 locations: Happy Valley, Goose Bay, Pinsbrook, and Bishop Falls. And you can avail at least a bunch of equipment. I'm not 100% sure. You probably have to ask the development officer if the operators come with these. I believe they do at times. You can have an operator and the equipment will come and do some of the work for you. So that's a very important asset to have. Like I say, we've got a lot of different programs that you can avail from. So contacting our staff or looking on our website will give you a good idea of what you can avail of and help you out. Like I said, I won't worry too much on this. Typically in Newfoundland, rock clearing happens after rough clearing. Once we do the rough clearing and the bare soil is there, that's when we do most of our clearing. This is just an example. So bare soil fields, that's when we do most of our clearing. Once there's crops and stuff like that in there, I know we get stones and rocks and stuff come back due to frost action, but basically only precision pickers or hand picking can get the stuff out of here without damaging the fields. So like when we do no-till systems and we leave all the residue and stubble behind, stones and stuff sometimes come up through. Precision pickers or hand picking is something you can use, but it's not overly prevalent in Newfoundland typically when we get our crops picked, but it's something that will become more prevalent as we get into these methods of agriculture with these no-tills and cover crops and minimal strip cropping and all that sort of stuff. So like I said, just plowed fields, Newfoundland soils derived from glacial till grow stones every year due to frost action from submerged stones getting pushed to the surface. So you'll do your initial rough clear, you'll get it all out there, but every year you're probably going to see a few coming back up that you'll have to get rid of. And that's where these precision pickers could actually come into play and start becoming a bit more prevalent in the province. Pasture land, won't get too much into that. So you got your land all picked. You've got the vegetation off it, you've got your coarse fragments gone, and now you're ready for whatever you're going to do with it. But there's one more step before you do planting. So this is just some pictures of newly cleared land. Look how nice it looks. It's nice soil. Everything's ready to go. Basically, you've got to get your soil tested and lime your ground. Lime can take up to a year to really be active and to work and to get your pH changed, sometimes 2 years, depending if you deep tilled and brought up acidic subsoil. But liming in the province, there's almost nowhere that you get away from using lime, and the government has a pretty good limestone program that you can avail of discounted limestone to use in your operation. And the soil samples are critical because if you don't have soil samples, you can't avail of our limestone program. It's only a win-win because the samples are only helping you in the long run, and they're valid for 1 year after the date that they've been submitted to the lab. So once you have that, then you can apply to the limestone program and you have a really good idea of exactly what nutrition you have and what you have to add to your soil to get whatever crop you want to have. And like I said, we've got a pretty good resources on our website, basically for the online limestone program and the fertility stuff. So it'll give you a really good indication of why you need lime, how you use it, where you get it, all that sort of stuff. Just a one quick note, this is going to be discussed further with the next modules back in probably February or in the winter. And it's just that we have a really good soil plant and feed laboratory here in Brookfield Road. And we can test just about anything. So we can test soil, soil amendments, plant tissue, feed that you're feeding to your livestock. And basically we do the soil, we give you the full, it gives you, I'm not even putting up a sample copy of our report. That will be discussed later with the fertility side of stuff. But just to know that we get a very comprehensive coverage of what is in your soil, what you need to do to your soil to get the crop that you want to do, how much of it to put there, and the time of the year that you should apply this stuff. And here's just a fee schedule and just the address and phone numbers and stuff. Like I said, it's $10.35 for a commercial farmer to get a sample, and it's well worth its weight in money. And for a home gardener, just whatever is $20 a sample. So once you got a soil sample, it just takes the questions out of it all, and you've got almost a science to growing your crop that you need to grow. Takes a lot of the guesswork out and trial and error, and you can be more successful a lot quicker. And that covers it. And that's a lot of talking and a lot of pictures and a lot of information. So if anyone has any questions, feel free to ask.
Quiet crowd.
I must have been really good because there's no questions.
Have a comment if you don't mind.
Oh,
Can you hear me okay?
yep.
Okay, I'm Sabrina Ellsworth. I'm just going to introduce myself. There's a lot of people on this in this group that I haven't met yet, I don't think, but I'm the director of Agricultural Production and Research Division, and our staff have worked really hard in putting these modules together in a fairly short amount of time. So Shawn and Yujao, who's here also, he's our soil fertility specialist. You guys did a great job. Thank you so much for working so hard on this for the young farmers. I just want to emphasize the equipment bank. Shawn mentioned it, and we do have 3, as we said, throughout the province, and we do have rock picking equipment, tillage equipment, seeding equipment, all sorts of things. And one of the nice things, if any of you are familiar with the program, there had been some limitations on insurance. And this year we have reduced the requirements for insurance. So now it's just a driver's license. So that we hope will make it more accessible to a lot of new farmers that are just getting their feet wet with production. The other thing that Shawn mentioned too is the ADOs. We have agricultural development officers, or ADOs, as most people would know them as. They're located specifically or regionally throughout the province, and they could be your first line of contact if you want to get in contact with anybody within the branch. If you need any support on any of the programs, those sorts of things. And soil fertility, Yujao is the person to help you interpret your report. So we do have a pretty large team in all aspects of agriculture. Extension specialists in crop and fruit and honeybees, livestock, sheep, beef, all of that. So we're all there to help you all with your farming adventure. So I just want to put that out there. So thank you again, Shawn. Thank you for the opportunity.
Oh, no problem. I'd like to say thanks to Jason and Crystal and you guys and you, Jay, and everyone else for helping out with all this stuff. And it has been a pretty intensive month. It's been, I think my hair's gotten a little grayer, but I'm glad that we got it done and we got it out here. And this is a good format to put it out there. And like I say, if we need to, we can probably do recordings of these and have them online or on our website that people can come up to in the future and look at. And the next couple of modules too, I think will be very informative, especially for the young farmers and with all the new global warming and carbon sequestration and regenerative agriculture and new methods of farming. It's going to be very informative to a lot of people. I learned a lot myself going through it actually as well. And it's very good, very smart, and it's something that pretty much everybody's going to have to get into, because just with the increasing population, the finite amount of land that we have, it's something that we're going to be more and more into, and it's going to be something that a lot more people are doing.
Yeah. And just one other thing, these are the soil modules that we're continuing to put together, but we have other modules that we're going to be developing too. And one of them is queen rearing for anybody interested in raising bees, and another one is beef production. So from the very basics of raising beef cattle in the province and finishing them. So those are other modules that we are going to be working on over the winter and hope to have ready for anybody who might be interested in the near future. So we will hopefully be putting this information on our website. we're not sure the format of that yet, but it should be accessible to as many people as possible. So to put that in there.
And one last thing too, I guess, is we may come next season, next summer. We have the potential, I think, to do a short field course in the field for soils and just determining suitable sites and that sort of stuff. So if anyone's interested, and just let us know and we can do that. I've already got something pretty much created for that one, and we've done something in the past where it was in-house for a little while, and then we go out in the field and actually look at what we were talking about. So yeah, that's definitely an option. Like I say, hands-on is great experience.